Yo, what's going on, everyone? How is everyone doing? It's been a couple days, but we're back. Oh my god, I'm cold. It's freezing outside. Oh my god, I'm lighting a little candle to warm up my hands. Cool. Probably get started in like 2 minutes. So far, Dark Space in the Twitch chat says up, up, down, down, left, right, BA select start, and that's the that's the hint of the day, or at least that's related to the puzzle today. And Andre says, "Here we go. This one's gonna hurt." And I have heard mumblings. I've heard mumblings of day 13 being tough, with which correct it was, and I've heard about day 21. So I'm excited. This is gonna be the last hump. We get over this, and then it's smooth sailing, in my opinion. So we'll see. Good luck, so excited. Going to miss the first part for dinner, but something tells me I'm still going to be here when I'm back. We'll see, but probably, yeah. Go enjoy your dinner. That sounds lovely. Oh, man. This is the goated technique for anyone who doesn't know. You get a candle. You just hold your hands over it. Oh, so nice. So nice. Warms them right up. What's up, Tablet Lenovo? How you doing? Yo, what's up, NNBB? How you been? Oh man, I'm excited for this. Whew. What's that fire thingy? It's kind of like my USB hand warmer, but more old school. Yeah. It's like the beta version of a USB hand warmer. So yeah, if you program exclusively in Bash, you also warm your hands by fire, and we grunt at people to communicate. So yeah. Oh boy. All right. Where's my phone? Oh, it's in my pocket. That makes sense, actually. I can't even explain. I can't even explain the song that's in my head. It's a song from a slot machine at the casino. Like, there's no way I could explain that. What's my explanation? Gamble too much? God, how awful. Alright. Oh my god. Hands are cold, but we're good. Dude, Twitch's dashboard is so not good. It tells me I'm offline, but then it's the stream says offline, then right underneath it says live with a red dot next to it saying excellent connection. So like, sure, dude. Whatever, man. Awesome. Alright, is everything good? Let's see. Twitch says I'm live. YouTube says I'm live, so I think we're good to go. Yeah. What say we get started? There we go. Look at this beautiful picture coming in. It's beautiful. I love it. Let's start the day off right? Or no, when we played piano, we cursed it last time, right? We're going to try not playing piano, or we're going to see what happens, okay? I like playing piano, but we're gonna just see what happens here. Is the terminal open? Yes, the terminal's open. Okay. What is this picture? Oh, that's when I did my collab with Bad Cop. Oh, not doing that. Looking forward for insights and flashbacks. It's gonna be fun. Yeah, I'm excited for this. Let's get started. Day 21. I can already see a keypad. It's named Keypad Conundrum. All right, give me 1 second. What's up, Code Cannon? How you doing? We're just about to jump into it, so you haven't missed anything. Day 21, Keypad Conundrum. As you teleport onto Santa's reindeer-class starship, the historians begin to panic. Someone from their search party is missing. Uh-oh. A quick lifeform scan by the ship's computer reveals that when the missing historian teleported, he arrived in another part of the ship. The door to that area is locked, but the computer can't open it. It can only be opened by physically typing the door codes, your puzzle input, on the numeric keypad on the door. Okay? The numeric keypad has 4 rows of buttons, 7, 8, 9, 4, 5, 6, 1, 2, 3, and finally an empty gap followed by 0 and A. Okay, so we have numbers and then we have an A button. Cool, this all makes sense. Unfortunately, the area outside the door is incorrectly depressurized and nobody can go near the door. A robot needs to be sent instead. Okay, fine. The robot has no problem navigating the ship and finding the numeric keypad, but it's not designed for button pushing. It can't be told to push a specific button directly. Instead, it has a robotic arm that can be controlled remotely via a directional keyboard. All right, okay, I'm following so far. The directional keypad has 2 rows of buttons. A gap right here, okay. Up, A for activate, and then left, down, right on the second. Okay, fine. Okay, so we have, WASD basically up, down, left, right here, a blank space on the left, and the A buttons on the top right as opposed to the bottom right on the above keypad. Cool. We have like a controller, like we're playing a video game. Got it. When the robot arrives at the numeric keypad, its robotic arm is pointed at the A button in the bottom right corner. Cool, so we start in the A button for the numeric keypad. After that, this directional keypad remote control must be used to maneuver the robotic arm. The up, down, left, right buttons cause it to move its arm 1 button in that direction, and the A button causes the robot to briefly move forward, pressing the button being aimed at by the robotic arm. Okay. Okay, I'm following this. So we have to use the keypad, but we have a single level of indirection here, which is this up, down, left, right pad. For example, to make the robot type 029A on the numeric keypad, one of the sequences of inputs on the directional keypad you could use is, okay, 029A. If we wanted to push that, we start on the A, so we have to press left, and then A to push this. Up, and then A to push this. So let's see. We have to press left to move the arm from the A to the 0. Okay, cool. A to push it. Up A to move it. Okay, yeah. I understand this. This makes sense. Okay, I'm following here. In total, there are 3 shortest possible sequence of button presses on this directional keypad that would cause the robot type 029A. Where are they different? Up, right, up, and up, right. Oh, okay. I'm following. So to go from 2 to 9 is where that happens, right? So if we want to, if we want to jump from 2 to 9, we have to go up, right, up, or up, right, up. Okay, so those are 3 of the paths to get you there, like a maze. Okay, and they all happen to get you there on the fastest thing, whatever. Unfortunately, the area containing this directional keypad remote control is currently experiencing high levels of radiation, and nobody can go near it. A robot needs to be sent instead. Okay. Okay. When the robot arrives at the directional keypad, its robot arm is pointed at the A button in the upper right corner. After that, a second different directional keypad remote control is used to control this robot. Oh my god, okay. So we have a second level of indirection here. Oh god, I see where this is going. There are multiple shortest possible sequences of directional keypad button presses that would cause this robot to tell the first robot to type 029A. Oh god, okay. So we have to use a keypad to control a robot that uses a keypad to control a robot that uses a numeric pad. Okay, so far we have 2 different pads, and we have 2 robots, and we have us, the prime mover. Okay. Unfortunately, the area... Come on, dude. Unfortunately, the area containing this second directional keypad remote is currently negative 40 degrees. Another robot will need to be sent there on the directional keypad, too. Okay. There are many shortest possible sequences of directional keypad button presses that would cause this robot to tell the second robot to tell the first robot to eventually... Okay. Robot 3, Robot 2, and Robot 1. Robot 3 is at a directional pad, Robot 2 is at a directional pad, and Robot 3 is at a numeric pad. We are at a directional pad. There are 3 directional pads and 1 numeric pad so far. This sucks. Look at these sequences. Look how much they grow. Oh my god. Unfortunately, you gotta be kidding me, dude. I'm gonna lose my mind already. I haven't even started. Unfortunately, the area containing this third directional keypad remote control is currently full of historians, so no robots can find a clear path there. Instead, you will have to type the sequence yourself. Okay, so no robots. Okay, you will have to type the sequence yourself. That's fine. Okay. Where you choose the sequence of a button presses. Here are all the buttons that would be pressed in your directional keypad, the 2 robots' directional keypads, and the numeric keypad. Oh god, okay. Here are the following keypads. 1 directional keypad that you are using, 2 directional keypads that robots are using, 1 directional keypad that a robot is using. Okay, so we have 2 different types of pad, numeric and directional. We have 3 robots, 2 using the directional ones that we're also using, and 1 using the numeric one. Okay, we can break this down. This is fine. It's important to remember that the robots are not designed for button pushing. In particular, if a robot arm is ever aimed at a gap where no button is present on the keypad, even for an instant, the robot will panic unrecoverably. So don't do that. Okay, so we treat gap, like if we're going to treat like a maze, we're going to treat the gap like an obstacle. We can't go there. That's not valid ever. Can we go out of bounds? Did it say anything about that? If a robot arm is ever aimed at a gap where no button is present on the keypad, even for an instant. I'm assuming that means no going out of bounds either, because there's no button present there. So don't do that. All robots will initially aim at the keypad's A key wherever it is. Okay, so everything resets to A. That's convenient. That's why I'm figuring no out of bounds, yeah. To unlock the door, 5 codes will need to be typed on its numeric keypad. Holy God, okay. For each of these, here is the shortest sequence of button presses you, the programmer, could type to cause the desired code to be typed in the numeric keypad. So I press these, which controls a robot who presses a directional pad, which controls a robot which presses a directional pad, which controls a robot which presses the numeric pad. Okay. The historians are getting nervous. The ship doesn't remember whether the missing historian is trapped in the area containing a giant electromagnetic or molten lava. You'll need to make sure that for each of the 5 codes, you find the shortest sequence of button presses necessary. The complexity of a single code, like 029A, is equal to the result of multiplying these 2 values. Oh, we have to generate... Okay, this is how we generate our checksum or our final answer. The complexity. The length of the shortest sequence of button presses you need to type on your directional keypad in order to cause the code to be typed in the numeric keyboard. For 029A, this would be 68. So yeah, if we were to take the length of this sequence, we would get 68, and that's how many button presses it cost us to do it. So we have to multiply that with the numeric part of the code, ignoring leading zeros. So for 029A, this would be 29. Okay, and all the codes end in A. I'll check the input to make sure they all end in A, but I'm guessing they're all going to end in A. So we just take the digits out of it. In the above example, the complexity of the 5 codes can be found by calculating 68 times 29, okay, adding them together. Okay, we've done this before. Find the fewest number of button presses that you'll need to perform in order to cause the robot in front of the door to type each code. Okay. Let's pause. This sucks. I don't like this. But my brain is spinning. And I think this is not... It sounds completely absurd, but I don't think this is going to be as brutal as I initially planned it. Because... a couple things. I'm just going to talk out loud. There's only 2 different types of keypads. There's a numeric keypad and a directional keypad. Those are static. Those never change. So we can start getting information about them before we even tackle the puzzle. And what I mean by getting information is like all these puzzles start at A. So we already know like a starting position. We can calculate shortest paths to get to every single possible thing. Like if we're at the A button, here's the sequence to get to 1. Here's the sequence from A to 2. Here's the sequence from A to 3. Yeah, and then if we do that, we know the reverse too. If we can get from A to 1 in the shortest path, reversing that set of sequences, taking the 180-degree rotation of each direction, if we reverse those sequences, that will get us from 2 to A or whatever. So we can go statically calculate this and create like a cache ahead of time where it's like, okay, here is what we can do with that. I don't know how this information can be useful. I'm just saying here's some of the stuff we can do with it. So we have to treat them like their own separate puzzles and basically solve them shortest path. And that's not going to be too bad. We could even cache these in files if we wanted to. What's up, Chai Towns? How you doing? Yeah, and then we need a lot of shortest paths. Okay, so for example, if we had just one level of indirection, right? Like we're controlling the controller, and that controls a robot. In order to jump from 0 to 2, we need the robot to press 0. The robot press 0. The robot doesn't need to press A to commit anything, right? Hold on. Do you have to press A after each move to commit it? Yeah, because we move the robot arm and then we press A to commit it. We don't need the numeric pad to press A unless the code itself has an A into it, which they typically do at the end of them. Let's start writing some code. Let's go over here and see what we got. This needs to move. Okay. Where are we? 2024. Awesome. Make dir day 21. Advent of code in Bash. How even? Yeah, so it's actually not possible. It's actually kind of like this long joke that I've been doing where I write code on stream and then I secretly, like, on a different terminal, pull up my Rust program and I just calculate the answer over there and then I use it. So it's all been a lie this whole time, actually. Also, yeah, we're doing Advent of Code 2025. So Eric actually gave us access to the new puzzles. So these are like super secret puzzles. No one shared them. Oh my god. Great, now I'm completely derailed. I completely forgot what I was doing. I wasn't even doing anything. I haven't even, like, tried anything yet. So, okay. In my opinion, you have to dive in to figure out the true meaning of shortest. Yeah, I just like to dive in anyways. I like to think and then code, think and then code. I don't like to get too bogged down in thinking and too bogged down in coding because you can kind of... hit a paralysis, and I've personally found that that's never been helpful in coding. Like, coding is like a muscle, man. You got to keep doing it. At least that's my experience with it. So we'll see. Hell yeah! All right, we got this. We got this, gamers. Lock in. What are we doing? Example. Input. Text. Dijkstra, show me the way. Oh my god, it's so funny. Like, I remember learning Dijkstra's algorithm in school and just like barely understanding it, and now I regret not taking the time to fully understand it because it'd be super useful here. Like, I do, but like I could have a better understanding of it, if that makes sense. Okay, here's something interesting. The real input is just as like low as the example input, and if I've learned anything from these puzzles, it's fear small real input. So yeah. Says I shouldn't use goto. Yo, okay. I got into not an argument. I got an argument over this with someone. I made a video talking about some code I wrote and see. Actually, wait. I could just pull it up, couldn't I? Yeah, wait. I have a web browser. What y'all know about a web browser? Someone made a pull request on some of my code that I talked about in a video, and it was nice. Like, it was super cool. I thought it was awesome that they made a pull request here. I wrote a program called SSHP. It's a parallel SSH thing. There are other programs that do it, but like, here you have like a list of hosts. You just like make a file with like a list of hosts that you want to SSH into, and you run this program, and it will just like, I don't know why I use screenshots. It'll just SSH into them and run the command, and you can do all sorts of things like get their exit code, see how long they took to run, print standard error in red, standard out in green, a whole bunch of stuff. It's all written in C. And someone made a pull request getting rid of my calls to goto in it, and they were like, gotos are bad, you should never use them. And I was like, I don't agree with that. Like, even in your pull request, you had to duplicate code to get rid of the gotos. Like, the gotos are elegant and fine. And they felt bad. They like apologized, like, I'm so sorry. I'm like, dude, it's fine. Like, don't apologize. You made a pull request. Like, you took time out of your day to make code for me. Like, I am infinitely appreciative of that. I just disagree with the reasoning and the logic. Not using GNU parallel. Yo, okay. You have to understand. How do I say this? I'm not good at Bash. No, I'm I'm good at Bash, but I'm not good at like Linux-isms. I never really like, my main server that I use is Illumos, which is forked off of Open Solaris. So I didn't even have like the GNU userland utility. So like GNU parallel, that's like brand new to me. I don't even know. I do not know how it works, to be honest. I should spend time learning it. But yeah. Do I use goto in here? Yeah, absolutely. Oh yeah, I read a file line by line with fgetS, and then I just go to next. If it's a comment, if it's a Blake line, if it's a new line, if it's the null byte, we just jump to the next one and we just try to iterate again. And all next does is do like line ++. So we count the line without actually, processing it, doing any sort of stuff here. What do I do here? Yeah, I make a linked list of all of the hosts in there. So, yeah. Oh, man, I love C. C is such an elegant language. Oh, my God. I mean, obviously Bash for life, but come on. C is beautiful. Is GNU Parallel really terrifying? Should I, take time to learn it? You know what? Actually, someone commented on one of my videos and said, something I made threads but not threads. I forked off external processes in Bash, subshells, and forked off a whole bunch of them. And they're like, you could use coproc to do this. And I was like, you know what? I've never used coproc in Bash. I should take the time to learn that. I know there's an 8-hour video of someone on YouTube reading the entire Bash manual, so maybe I could just go there and find coproc. But xargs-p, is that a thing? I mean, I don't doubt that it's a thing. How portable is that thing? Will my Mac have it? Oh yeah, Max Procs. Huh. Interesting. Parallel mode. Yeah. Wow, that's so cool. I didn't know that existed. That's awesome. Let me see something. Do I have it on Illumos? Oh my god, I do. Wait, which... This isn't GNU. This isn't GNU xargs, is it? How would I tell? Get the help message? This is not GNU. Wow, okay. Is dash capital P POSIX or everything just implemented because it's useful? I could see the latter. That's really cool, though. Huh, that's sick. I haven't read that paper since college. Go-to considered harmful. I think at the time it was a main control structure and people would go to real far away. Yeah, I think there's something to be said there. It's so tough. I think it's one of those things where if you're coming from assembly and you're trying to learn a higher level language like C, you're going to be tempted to use go-tos everywhere. And I could see someone saying hey guys, lay off the go-to. But we interpreted it through our modern lens. We're like, oh, we should never use go-to. It's that's not true, dude. I'll go to the top of a loop or something. I can understand. You go to a different function with a different scope and you're branching out there. Hey man, you're kind of, make sure you know what you're doing. I understand that, but yeah, I've definitely used go-to in loops and stuff. Or go-to to jump to the bottom of a function to, deallocate memory, things like that, free up memory, close file handles, things like that. Go-to is only good for breaking out nested loops. Yeah, I could see that. Like I said, for the other one, I use it for jumping to the bottom of a function if I need a cleanup function. In Rust, you have the implicit call to drop at the end of a scope. Golang, I think it has a defer. It's kind of like that. I think Python even has try catch or try except finally, I think is a thing. I haven't read POSIX is too long. Yo, that's fair. Honestly, that's fair. Oh, man. Error handling is an exception. Bad Cop, I don't know if you intended that sentence to be as deep as it actually is. The double meaning there is incredible. Yeah. You know what? It's so funny. I believe that you did. I've talked to you enough to believe that 100% you intended that. That's impressive. I love that. All right. Let's do this. Let's lock in. Okay, what do we have? So the way I want to approach this is... we have two keypads. I want to take both keypads and solve them. What I mean by solve them is I'm going to treat them like a maze, and I want to find the shortest path from everywhere because we can just cache that information. I think that'll be useful to start. So let me show you what I mean. We'll make numeric keypad.text, and the numeric keypad is 789 456 123 #0A. Now the pound sign will be a wall. We cannot go through the wall. And we're going to treat this like a maze. We're literally going to solve this. We've written code to solve mazes before. We're going to vim directional keypad.text. And our directional keypad will look like pound sign, up arrow A, left, down, right. So now we have two mazes here. We have our numeric keypad, and we have our directional keypad. And we are going to have to solve these mazes, I believe. So we always start at the A. Oh, but the robot's hand's going to hover over them. It doesn't actually have to. We need... I think we need every path. I think for every one of these, like, we literally need every path. Like, if we're at 7, we need to know how to jump to every single one of these things in the shortest path. If there's multiple ways to get there, who cares? We just pick one, because at the end of the day, we just want that number. We just grab the shortest path. Yeah, we're literally gonna have to use the shortest path algorithm that we have and be like, okay, let's solve it from 7 to A. Okay. We can do this. We can do this because we've written code like this before. I don't remember where it was. Where do we do that bread first? Where do we do bread first search? Can I just like search for it? Day 18, part 2? No. Day 16 it must be. Part 1. Day 14, you think? Yeah. We'll see. I've done it. I've done it a couple times. Oh yeah, this is the one that kept track of the turns, didn't it? This is it. Yep, this is it. And we put them to the end of the queue. Okay. Here's what we're going to do. CP day 18 part 1 into day 21. I don't know. We'll just call it solver for now. It's not going to be part 1. We're going to make like some intermediate things. I didn't go to where I expected to. Vim solver. All right. So we're going to do this. Oh, is there simulating bytes falling? Yeah, I remember this. Okay. Where do we read in the map? Oh, right, because this is not a read in the map type of thing. This is fine. While read -r line do done. Width equals line, height equals 0, height plus, and then we do a for x equals 0, x less than width, x plus, do. We're gonna just read in the data that we pass it over standard in. We'll get the character at that location, which is line at location x for one character. We're gonna substring it. And then we're going to store that in the grid. The key is with x comma height. And then we'll do grid key equals c. So we'll read the whole thing in. We'll print grid. And then we'll exit right here. So if we run solver on the directional keypad, it will recreate that, which is good. Doesn't look like much, but we are recreating the grid using Bash's internal representation of it. So that's really good. So now we have to solve it. And we have to solve it for every possible place in it. Yeah, for every place we have to solve it to every possible place, and we can store it. Okay. So let's make a cache of all the solutions. And let's loop through every possible character and solve it to every other possible character. We can do this. We can definitely do this. It sucks, but we can do it. Every location is going to be a key in the grid. So for key 1 in grid, do for key 2 in grid, do key 1 equals key 2. We don't need to solve it going to itself because we know the fastest path there. I mean, I guess we could technically store it if you want to go like to and from itself would just be 0. You're already there. Yeah, let's not even filter that out. Let's just let the algorithm do that. And the solutions will be, yeah, we'll figure it out. solving for key 1 to key 2. Exit. Okay. So we're going to go through every possible place in the map, and we're going to solve how to get there in the most efficient way, assuming a robot arm is walking over it. And I think this information will be useful. Did I? Give me a second. I think I have that logic in a function in part 2, right? I do. Yeah, let's just totally steal this logic. Where is it? Right here. We only have one numpad. Do we really need all paths? I don't know yet, but that's what we're just going to get this information. Okay, I think this just works. What does it take? Because we should give it some functions, I think. Or we should give it some arguments. Probably a start location and end location. Okay, I think we can do this. Start location, end location. And then we need to solve maze key 1 to key 2. And then it should store its solution in the array called solutions. Yeah. We have solutions here. So once we get to the end and we win, yay, we need our path now, lol. How do you keep track of the path? Did we just put it on the end? Oh, we know what we do. We keep track of the moves we make. Let me think. Yo, what's up, Alex? How you doing, man? Happy to see you. Yo, yeah, welcome. One of the rare few who's made it over from my music channel over here. It seems like I have totally different audiences for people who want music and people who want programming. So it's actually really funny that that works out like that. Okay. We keep track of the start location. When we queue up the next thing, we also need to embed some extra information, which is the move that we made to get there. Yeah. And in this case, we didn't do any moves to get there. Okay. We don't want the bad luck piano. I know, I'm afraid of it. I'm afraid of it. I want to play it, but I know it's bad luck. Okay, so we've pulled out the list of moves that we've made. If we win, then solutions. Start location. I could totally do like an arrow or something. I'll just do a pipe. just call it S key is the start location, pipe, the end location, S key equals moves. Okay, so this will store all the moves as the solution, which will just be one character. So every time we do this, we have to comma moves, and then we just append the move that we're making. So in this case, we're going north, so we append an upward thing, because this will just be a string that constantly gets appended to. Moving south, we're going down. Moving east, we go that way. Nope, that's west. And we're going west, then we go that way. All right. Let's not return. Let's just bail out here. Good evening to you. What's up, Robin? How you doing? Welcome. Happy Julian New Year, by the way. Ooh, fancy. Thank you. I didn't even know that was a thing. But you as well. Okay, so we went through and we solved all the mazes. If we get down here, then we should just var dump what we have in solutions. And what is var dump, you may ask? It's a little library I wrote to dump a variable. And we're going to pull it in. We've used it in previous puzzles. I'm going to assume we used it in day 20. Yeah, I really like this variable. Okay, I think if we just run this... Hear me out. Solver, give it the, I don't know, directional one because it's small. Maze is unsolvable from... Oh, yeah, okay. We have to do some quick checking here. If it's... if either character is a pound sign, then we just don't care. Oh, do I have a typo? I'll check that out. Thank you. Local C1 equals grid at start loc. Key 1, key 2. And I think where I declare this, yeah, these are wrong. Solving for start loc and end loc. Otherwise, we're just going to use the global ones, which is totally fine. Because we're only running this one at a time, but theoretically we could parallelize this and that would become a problem. C2, end loc, nice. C1 equals pound sign, and return. C2 equals pound sign and return. So if either one of them is a pound sign, then we just return. So this should run through all the possible things. Okay. We're close. We're close. We're close. I shouldn't call it end locations, end lock. Also, we don't care. Oh, we don't care what those numbers are. We don't care what the positions are. Let me think about this. I mean, we do, but maybe it's better just to know like yeah, we don't care what positions we are. We care what character is underneath us. I'm trying to think of how to cache this, because right now we cache it as, 2, 0 to 1, 0. We could cache it as like, 7 to 8 or something. So if we reverse one of these, if we had like 0, 1 to 1, 0, it's right up. If we had 1, 0 to 0, 1, 1, 0 to 0, 1, it's down left. Okay, so it is reversed. Okay. You haven't been working on this one for very long. No, I have not. So it hasn't crushed us yet. Yeah, okay, we're getting some good solutions. We're getting some good solutions. Let me pipe this to grep equal. Can I do that? All right, how many of these do we have? We have 25. Is that what we expect for a directional? We have 5, right? It'd be 5 raise 5, wouldn't it? Or no, it's not 5 raise 5. Sorry, 5 times 5. That's how many solutions there would be. I think that's correct. So if we do this for the numeric keypad, we'll get a lot more. Okay, grep for equal. What should we have here? 11 times 11. Is that what you have? Is that 121? Okay, yeah. Yeah, okay. So this is at least correct. Now, I don't know if these solutions are correct. Also, we keep track of how much it takes to go. Oh, this is cool. This is cool. I have some I have some pretty funny things we can do here. What are we gonna do when you're done with all 25 days? Oh, don't worry, I'm still gonna be streaming, and I'll definitely be streaming some programming stuff. I don't know exactly what. I like streaming. We're gonna be streaming. If I don't have any like fun content of my own to do, I'm going through Advent of Code previous years. Oh yeah, I definitely want to go through more of these puzzles. So we'll just jump right back to like 2016, 2015. It's 2016, I think, and just start going through it. I think we can do something really, really crazy here. Like, we var dumped the solutions. We could do this. Echo solutions at, is it Q? To quote them? That's not right. Man bash. Transformation. Yeah, cap A. So here's what we're going to do. This is going to be really gross, but I think we can do this. That's not what I wanted. Oh, it doesn't give me everything. What? I'm looking for something else. Hold on. I'm trying to find a way to dump this in a way that we can read it back in and re-eval it. Oh, I might have, you know what I might have to do? I might have to do the notation for an array. Yeah, I might have to do this. Yeah, okay. So I could dump this entire thing to a file, and then you can just read it back in. Like, we could totally just read it back in. I think that's what we're going to do. So then if I read the directional one, this one should be a lot shorter. Yeah, okay. And that tells us the grid locations. Now, it doesn't tell us the numbers. We could do a number to grid location and a grid location to number thing. I don't know what maps we'd need. But we could totally do something like that. Wow, this is so funny. Yeah, I wonder if we should just store both. Because I don't know which one's going to be useful, and this is the danger where we just start storing both. But we have C1 and we have C2. So where we store solutions, we could do like, we could just store another thing in there. So solutions S key equals C1 pipe C2. And then we could also store that one because they won't overlap. So now we're going to have twice as many, but inside there we're going to have like, yeah, A pipe to the down arrow. So if you want to go from A to the down arrow, here's how. Here's how. If you want to go from the left to the down, here's how. If you want to go from the up to the down, here's how. So that's what we're going to store. So, ready for this? We can do this. We can take this and write it to a file. We can say directional steps and numeric steps. And now we have these two new files that we can actually just read into our part one solution. So we're actually making some really, really good headway here. Again, I don't know how we're going to use this, but I think this is going to be a useful thing to have. So let's go ahead and start writing part one, right? Because part one needs to read the example input. So let's start getting that logic out. Example input looks like this. It's literally just a line or a new line separated file. Super easy. we can literally just read every single thing. And we can, oh my God, read array dash T. We'll just call it codes. And then we can just do for code in codes, do echo solving code, done. There we go. So now we've read the whole thing into an array and we just looped over it. We don't even need to really read an array. We could have just done it line by line, but like, so now when we read in from example input, it'll just say that. Cool. So now we know we can do some calculations. Once we solve the code, what are we going to have? We're going to have a complexity score. So the complexity score is, I'll show you. The length of the shortest sequence of button presses you need to type, and the numeric part of the code. So we can get the numeric part of the code at least. Go back to the terminal. Numeric equals, I think we can just do code replace non 0 through 9 with nothing. I think this is valid. Cool, so now we just have the numeric part of the code. We need to chop off any leading zeros. So numeric equals numeric pound pound 0. And now we've chopped off the leading zeros. So now we have the numeric part of the code. Cool. So what do we have to do now? We need to figure out a way. Oh God, this is the stuff that we have to press to get a robot to press this, to get a robot to press this, to get a robot to press this. Let me just write some notes for myself. We have, you can't see it, it's fine. I'm just copying basically what's here. One directional keypad for me, one directional keypad. I'll just show you guys actually, this makes more sense. For robot, one directional keypad for robot, one numeric keypad for robot. That's what we have. So we push buttons directly. Okay. And then when we press the A button, it causes the robot below us to commit to whatever its hand is currently over, which causes the robot to commit to whatever its hand is over, which causes the robot to commit to whatever its hand is over. Okay, cool. So I give up. No, I'm just kidding. Let's figure out how we're going to actually do this. Because this is going to be actually gnarly. Man. All right, let's take a little break. How's everyone doing tonight? How does everyone feel about this puzzle? I can see why people were afraid of this puzzle and why people said it's going to be a doozy. And I think it is going to be a doozy. But so far, every little problem has seemed approachable, so I'm not too scared. I don't know what part 2 is going to be. So that could just throw a wrench in the whole thing. Part 2 could be like, uh-oh, there's actually 18 trillion robots. Like, who knows? But I don't want to think that far ahead. I'd rather just deal with problems as they come up. So I think I know the answer. What's the answer? How everyone's doing? I don't even remember what question I asked. Listen, I kind of tune myself out when I talk. I'm going to be real. Oh, man. Dark Space, how did you feel about how'd you feel about this puzzle in general? Did you enjoy it? Was it a cluster fun? How'd you feel about it? Do you solve from bottom up? I don't know how I'm going to solve this. I'm going to be totally honest. I think I'll probably... I haven't even thought about that yet. So I haven't even put any brain power into it. Once I do that, I'll jump into it. So give me 30 seconds, then I'll fire off my brain into thinking about it. Right now, I'm just thinking about warming up my hands. And I also probably need to I'll make a protein shake soon. Man, I'm cold. Heart rate's at a cool 77. Nice. There was one major error I made, but other than that, it wasn't that bad. Nice. Okay, cool. That's good. Was the error completely user, or was it like something ambiguous with the commands? Because, man, I have made some gnarly user-only errors here, where if I had just read the instructions, I'd be so much better off. Oh, man. All right, let's see. Okay. Every pointer starts at A. So here's the thing. Everything starts at A. So every initial position is wherever A is, which could be at different things, but that's what we know. Let's read in our caches. What are our we have numeric, we have our step file has caches in it. Oh yeah, and they're going to overwrite each other. So let's go ahead and, this is directional steps, and this will be numeric steps is what we'll call them. So now we can just read those in. They call it numeric or numerical? Numeric. I need to be consistent. Okay. I just want to say the sample answers aren't wrong and you didn't find a better solution. Oh no. That's really funny. User error. Okay, fair enough, fair enough. Let's see. The most dumb solution of the first part gave me the answer, but the second part made flashbacks. All right, I'm excited for this then. Let's go ahead and run part 1 and just make sure everything still works how we expect it to. Awesome. Cool. So let me think about how we want to do this. I'm looking at this over here. So here is what we're given. We're given 029A. We want to press 029A. In order to do that, we need to move the robot from, the robot is currently positioned at A. So there's an implicit starting point of A at the beginning of this left one. We need to go from A to 0. So, okay, I'm gonna write a small little terminal command to explain what I'm thinking. CP part 1 to steps required. I'm making a new program. We're gonna just read these two things in, and we're gonna take the steps required for the type of keypad from and to. That's what we're gonna take. So type equals 1, from equals 2, and 2 equals 3. That's confusing. Let's call this start. No. We'll keep it as from and to. Yo, what's up, Roy? How you doing, man? Got some sweet hair. Yo, I'm working on it, man. I've been growing it for a long time. Oof. It's looking sick. It's long. It's awesome. Type from and to. Okay, so our types are... we have numeric and directional. So we'll just say yeah, here's what we'll do. Case type in numeric or just the letter N. We will get key equals from pipe 2. We will get numeric steps at that key. Oh, we'll just print it out. Oh my god, yeah. We just print that out. That's it. Oh, this is easy. Okay. Directional or D. We'll get directional steps at that. And if it's anything else, we just exit 1. And there we go. So now we have this steps required. Oh, did I have a typo somewhere? Oh yeah, look at this. $4. I'm awesome. I definitely know what I'm doing. Let's see. So now we have this program called steps required. If we are on the numeric keypad and we want to go from, we start at A and we want to go to 0, those are the steps required to get there. Does that make sense? Yes, because the numeric keyboard, yeah, you have to just go left to get there. If we are at A and we want to go to 9, those are the steps we take there. If we're at 9 and we want to go to A, we can do that. Hey, this seems useful, right? What if we're on the directional keypad and we're at left and we want to go right? Hey, look at this. This seems useful. Like, I'll be able to do something with this maybe if I can turn my brain on. So let's go to our example. The example is here. So we need to go from A to 0, because we start at A and we go to 0. In order to do that, we've already run that calculation. A to 0, we just need to move left. So in order to do left, this robot has to press left and then enter, which is A, because you have to commit it every time. So it starts at A. We have to move it to left. Oh, no, hold on. Yeah, this keypad needs to press left and then press A, but it's a robot. So in order to do that, we have to tell it to go to the left arrow, and it's a directional pad. So it has to go down and then left, which is what it tells it to do here. Down, left, A. Oh my God. Everything presses A to commit its action. A is required to commit and A is required to start. So every time we move somewhere, we pretty much always have to move back after we've committed it. So our question is, oh my God, okay, hold on, my brain's working. We have to basically explode, for lack of a better term, this into the steps required to press it and get us to A, and the steps required to press that is this. Okay, and the steps required to press that is any some number of these. So what does that mean? What does that mean for us? Okay. We have all these little, like, functions. I do like steps required. I like steps required as like its own little function. I might just pull this into part 1. Yeah, let's just take this. No, you know what? Let's be good, right? We already have this here. Why don't we pull this into a function? Steps required. Okay. Now we have a function. And now we can say, if not, return all output to dev null. This is like Python's, like if name equals main or whatever. So if we're running this interactively, like we've actually executed this directly, then we will run the function. Otherwise, we will just let it be sourced in. So I can still run it. You can't see what I'm typing at all. Oh my God, I just realized I wasn't sharing the terminal. I'm super dumb. Web page showing. Thank you. I'm dumb. My bad. Here's what I did. I moved everything that was in steps required into a function. And then I have this little bit down here. This is sort of like, saying like, if we're running, if I run this script outright, it will execute the function for us. If I source the script, it won't execute anything. It will just define the functions. So I can still technically run steps required, numeric, I don't know, 7 to 5. Let's make sure I type everything correctly. Oh yeah. Okay, cool. So that works. And then we can get the length of that string, and then we can figure out, how many steps it actually took. So the question then becomes in part 1, let's pull in steps required. In fact, we don't even need these because steps required pulls those in. So in order to type in that first code, from equals, yeah, here we go. Okay. We always start at A. So we have to loop over every character in this and look at the one that came before it. Yeah, that's what we have to do. len equals the length of code, which should always be 4. For I equals 0, I less than len, I plus plus, do, done. So from equals the code at spot I minus 1, or the letter A if it's not defined, 2 is the code at I. Echo calculate from 2. Let's just make sure this works, because this should kind of explain what my thought process are. What I'm going to do is I'm also going to toss an exit at the bottom of this. We're going to break out of it early, and that way we're only going to process one code, so we don't get overwhelmed by multiple codes. Okay, so that didn't work. Bad array subscript. I already know what I did wrong. Yeah, code is not an array. You can't index it like this. We have to use this notation. Oh yeah, it's going to be kind of ugly if we do it that way. That's okay, I think. Okay, A to 0, 0 to 2, 2 to 9, 9 to A. Hey, that worked. Why did that work? Wait, hold on. Why did that work? Why did that get A there? When I indexed it at -1. Oh, it pulled it from the end. That's actually not great that it did that. Let's just manually control it. If I equals 0, then from equals A, else, then we grab it from there. Okay. Yeah, that happened to work, but that shouldn't have worked. I just full screened that somehow? Didn't even know it was possible. Okay, in order to do that, we have to calculate A to 0, 0 to 2, 2 to 9, and 9 to A. Okay. Okay. So in order to do that, we have to imagine we go up the stack of directional key pressers. So steps equals steps required on a numeric keypad from 2. This is that function we wrote. So now if we print the steps, this should tell us the steps that we need to take. Okay, cool. In order to go from A to 0, we have to take this step. In order to go from 0 to 2, we take this step. In order to go from 2 to 9, we take this step. In order to go from 9 to A, we take this step. That's wild. That's absolutely wild. But it's all right. In order to go from 9 to A, we go down, down, down. In order to go from 2 to 9, we go up, up, right. This is crazy. Okay. You want me to rewrite all of them in Rust? Is that going to be the new content going forward? Oh, man. Okay, so what do we do now that we have this information? We know what steps it takes to go left. So in order to do that, what do we do? We have to... We have to put... No, tablet, slow down. Don't give me solutions. You're don't think ahead. It's okay if you correct me what I don't have, but don't think ahead. But that is what I'm getting. That was the next thing on my brain. Was now that I have these, I need to actually make them go there. Yeah, because if I were to put the letter A after each one of these, I would have what the second level has, which is what the third robot should be doing. Yay, Bash. Yo, that's right. Welcome. Welcome. We're finally in a real language here, like Bash. So these are the steps taken to go from A to 0. We have to go left, and then we have to commit it. We have to go up here, and then we have to commit it. We have to go here, and then we have to commit it. We have to go there, and we have to commit it. Okay. So to do that, How else would you do things badly with great speed? I don't know who told you Bash is fast, but they lied to you. When I need great speed, I don't go for Bash. Okay. Let's do this. All steps equals an empty string. Steps plus equal steps and then the letter A, because we have to commit them all. Echo all steps. Okay. 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 So if I did this right, this string should be what the second robot's doing in the example output from the website. I'm going to go ahead and grab that and paste that in just so we can compare it easily. Up, up, right, right, up, up. It's the same thing. It will get you there effectively. My algorithm just gave me a different one, but that's the same cost. This is right. Okay. Parsing things is usually where I leave Bash and reach for Python or Perl, depending on the system. Yeah, I can completely understand that. Absolutely. I'm trying to get better at Bash. Everyone at my work thinks Rust is something that happens to metal. That's so funny. Yeah, no. Like, don't get me wrong. I love Bash, of course. I love Bash, and it's amazing. But I would definitely not reach for... If I needed speed, like, on the metal performance, I'm not reaching for Bash. If I needed speed of development time, oh, yeah, I'm absolutely reaching for, like, a shell script or something. All right, so these are all the steps it would take. Oh my god, I think we have the solution. Like, I think this is it. Okay, hold on. Let's put this into a function. What's the name of a function for going up one level? Calculate steps, I guess. We'll just call it that. And let's clean this up. Let's go ahead and make a bunch of stuff local. The code that we are currently processing. No, let's do type as $1. So you have to give it a type if it's numeric or directional. And we have to give it the code that we're actually processing, which will be $2. Then we can grab the length of the code. We can grab all steps required. You can do local I to from steps. Okay. You have the absolute bash chads who write acme.sh. I've looked at acme a little bit. I think it's actually POSIX shell, isn't it? I'd have to double check it. But yeah, dude, I run acme.sh for some certs on my home network. It's awesome. Bash can be pretty efficient as parsing simple things like a CSV if you use the IFS. Oh, no, hold on. Bash can parse values separated by commas, but if you're talking CSV where the value itself could contain a comma, if it's properly quoted, you're going to need something more robust than the IFS, my friend. That's like saying JavaScript is super fast at parsing JSON with eval. It totally is. Just hope that JSON is right and not malicious. I think it might be POSIX shell, but I'd have to double check. I didn't say it'll replace awk. Yo, I love awk. Oh my god. We've used awk in some of our solutions here just to quickly get math solutions. Let's get rid of these. Steps required, and then we commit them, and then we echo all steps. Okay, so now that we did that, we have a type and a code. The type is numeric, right? And the code is the code. I think that's right. And then we end up with this, which is right. This is correct. This is the first layer of code. We will have to do this multiple times. So we can do it just once here. I think we're making really good progress here, actually, which is insane. Like, really crazy progress. Yeah, because now that we have this, we can do like A equals this, B equals calculate steps directional of A. C equals calculate directional steps of B. And we can just print these along the way, right? We could just print like echo code, echo A, echo B and C. Okay, well that didn't quite work out the way I wanted it to. But let's take a quick little break. I use Bash for a cron job that W gets a file of IPs to add to a local system's firewall. It's nice saving the overhead of having to spawn out more than just one cron process with no prereqs in the system. Oh, yo, I actually do something very similar to that. Yeah, I have on my DNS server at home, I have a cron job that every morning wakes up and grabs a list of hosts to block to get rid of, like, ads and tracking and stuff like that. And then, if it checks if that list has been updated and it's different than what it was the last time it pulled it, it will restart my DNS service. It'll reload it, so it reloads that file. But yeah, same idea. It's just so nice. I have my hint written out. I don't need it yet, but thank you. Thank you. Okay, so obviously this is wrong and that's wrong. And it's just because we're appending empty strings to it. So that's not a big deal. We can figure out what's going on here. Okay, so oh no, that's not how. Well, no, it is how it works. Now, steps required is just for one thing, right? Yeah, this is just for a one thing. All hints already in the chat. Scroll back if you need one. I don't need a hint. Guys, stop. Stop. Dark space, you're fine. I don't need hints. There's hints already in the chat. Go delete them. I don't want them there. I'm not even close to a point where I'm getting stumped here. I'm just working through it at my pace. And if you've watched my streams enough, you know that it works out just fine. Right, that would never work because it just takes one and gives you the steps from and to. So what am I doing wrong? Let's find out. No help unless ask for from me. The handsome emote. You aren't using tip yet. Guys, no hints. No, you're fine because I know it's a bug, but pause here. Give me more than 1 minute to find a bug. I'm not even close to being frustrated yet. In the Twitch chat, I give you a pass. I've already told you it's okay to show me bugs. That's fine, but give me more than a minute, okay? That's it. That's it. Yeah, no, I'm not mad at anyone. No offense taken. Don't worry. Just letting you know, like, I'm not even close to being frustrated with this program. I'm still in debugging and coding mode. It's fine. I'm not upset. We're good. We are good. Okay. Have the IDE replace tabs with 4 spaces? Yeah, get out of here. We're out of here. There's a command line tool that does that, right? Spaces are superior? Absolutely not. Hard tabs. Absolutely. 8 space tabs in my... Hard tabs, and then you set it to whatever spaces you want in your editor, but I assume 80. Yeah, no, there's a POSIX command specifically for turning tabs into spaces. Expand. I think expand and unexpand. Yeah. These are POSIX commands. They're guaranteed to be there. You can pipe in something with tabs and it will turn them into 8 spaces. Of course, you can change what that is and then go back and forth. So, yeah, I could take like my script part 1, which looks like that when I cat it, pipe it to expand, It looks exactly the same, but now it's turned them into 8 spaces. Let's see. I think I can, yeah, can you just do -T? -T1? I can make it 1 space. I can make it 2 spaces. You could do that. Yeah, that's an easy way to do that. I usually just use sed, but that's problematic. Yeah, you can get into some weird issues when it comes to like locales and stuff like that. I think expand kind of handles a lot of that stuff for you. Set expand tabs in Vim. I absolutely do that. Yep, I set ET. I think it's in my Vim RC. Or maybe I don't do that. I don't remember. It's been so long. Maybe I don't. Tab stop 8. Yeah. 80 columns my text width. But there is more that I do. I include this file called vimrc.indent, and I use a little program I wrote called tab stop, where I can specifically set a language. So when I'm editing someone's code, I could be like tab stop C4, and now suddenly all C programs will be, you know, done to 4 spaces. So I can work in someone else's environment if I have to, but I don't prefer to do it that way. But yeah, the indent file, all that script does is just manage this indent file, which looks like this. So I just set the no expand tab or whatever, and expand tab if it's less than 8 or something. So that's how I do it. Okay. Type code. Okay, yeah. Yeah. Right here. Tip. There we go. That's never going to work. Read in from example input. Okay. Okay, cool. How do you transfer your VimRC to other machines? I don't really. If I do, I check it out. It's all stored in a GitHub repo. So I literally have a GitHub repo called my .files, and I just pull it from there. Now the question is this right? Because it definitely expanded. What we could do is we could calculate the complexity score of each one. Let me remember how to do this. Do you know about GNU Stow? I know it exists, and I know people have recommended I check it out. I'm not super versed in the GNU utilities. Like Bad Cop was telling me about, you know, GNU Parallel earlier. I don't even know that. I know Stow is a thing. I've never looked into it, so I don't know what it does. I know it roughly does some sort of like .file management and possibly some symlinking. I literally know nothing beyond that. And that's just me trying to glean information off of random Instagram comments that I get. Oh, man. How do we do this? The length of the shortest sequence and the numeric part of the code, and then we add them all together. Okay. So the shortest sequence, 99% there. Yeah. It's amazing what you can get off of just reading enough Instagram comments. So yeah, okay, cool. This puzzle doesn't seem too bad. If part 1 doesn't seem bad, that scares me for part 2. We have the numeric part of the code. We need the length of the shortest code to get there, which is the length of C. And then and then we need to multiply those together, get the product. So results equals numeric times len, and then I think we need a global accumulator where we do accum plus equal result. There we go. Get rid of this exit, and then we can echo total is accum. And when we're down here, we could do echo code C. Now let's just do the result. So if we run this now, okay, our total is 131946, and we should get 126384. Okay, so we are wrong. We are slightly higher, but not by much. So I'm willing to bet that we've done something extraneous that we don't need to. Yeah, we've done something extraneous here. And we'll just have to figure out what that is. Almost there. Yeah, exactly. We're so close. We're like super close. The numeric part of the code. The length of the shortest sequence of button presses you need to type in your directional pad. This would be 68. Okay. Let's do some installing. GNU Stow is a symlink farm manager which takes distinct sets of software and or data located in separate directories in the file system and makes them all appear to be installed in a single directory. In my that's funny. That's really funny. In my .files repo, I'll pull it up for you guys. I've showed it a couple times on stream. Yeah, in my .file repos here, where I keep my .files, 161 people have starred my .files. Dude, it's weird being famous on the internet. I have something called install, and it's a bash script that just basically does this. So I have like a function called symlink, and then I just go through and literally symlink my .files into the home directory. Like, this is it. Like, this is literally how I do it. I don't know when GNU Stow was created. I don't even know when I wrote this. When did I write this? You can view history for a given file, right? There's a way to do this. I could git blame it. That doesn't help me. I mean, it probably does. Why would I have ever changed the shebang of this file? There's a way to see history, I know, for a given file. I don't know. I don't know the GitHub UI. Yeah, adding install script. So 13 years ago. Yeah. So I don't know how old GNU Stow it is. It probably predates this, to be honest. But literally, it's 13 years ago is when I made this install script that has changed. Here's mine for setting up .files and everything else. Oh yeah, let me check it out. Don't open in a stupid. It's gonna open in a different browser. It loves to do that. Okay, so you pull in Stow. Gotcha. Ah, you installed NeoVim manually. That's awesome. Oh, that's smart. You actually do the Git setup. I checked in my Git thing that has my email and stuff in it. Yeah, and I ran into this issue where some people were like committing things under the name Dave Eddy. I was like, dude, come on. Interesting. Okay. Wow, okay. So Stow really does make it simpler for you. Okay, gotcha. Bro, this is an involved process. Yeah, this is awesome, though. All right, let's get back into it. We're super close to the answer. Let's go ahead and get the answer. Let's not get sidetracked. I'm going to start printing out more things that are useful. And less things that are not useful. Okay, so that's the score for each one. And let's print how we got that score. We got that score by numeric times len equals result. Because now we can compare it to what's on the website. So the website says 68 times 29, 60 times 980. That's not right. So I'll just cross-reference these. 29 times 70. It has 29 times 68. Okay, so it has 2 less. 980 times 60, we have 980 times 62. 2 less. 179 times 70, we have 179 times 68. 64, we have 66. And 64, we have 70. Okay. So we were off by 2 until the very end. All right, so we're off then. Okay. So we're doing something funky here. but that's okay. We're going to figure out what that is. Once we get down here, we can print out the final code, and we can compare it to what each one has. Okay. Ah, man, this sucks. Let's just spot check one. Here's what we'll do. We're going to grab this first code, vim notes.txt, mine, Eric, and that's what the creator of the puzzle has, Eric. I needed something that had 4 letters. Okay, so we can already see the most challenging thing is to keep silence. Yeah, well, accept that challenge. So what do we do here? Okay, I can already see a problem here. We have a double commit where we didn't commit something. So I'm guessing that we are not handling not having to move our thing, but having to commit something. That's my initial hunch. Let's go ahead and space this out so things connect more again. We got off here somewhere. Let's go back to the first example because, yeah. Let's go here, exit, and let's redo this. And we're going to compare it to what the, okay. So we have this, and what they have on the website is backwards than what we have, but that's okay. We can just compare it. I'm going to copy and paste from the website. We're going to see where we went wrong. Okay. All right. So we have the same length there. Same length here. It's only when we get to this final thing that we are not quite there. All right. So let's store, this is the good output here. Yeah, let's go yank this, put it there. It's the same. Let's go yank this, put it here. Functionally the same. Yank this, put it here. Visually, I'm lining up the A's. This is not the same. This is interesting. This one went down and hit A. Yeah, down and hit A. We went left and hit A. Why did that happen? Let's see. In order to go left, we had to move down from A to the left twice and then commit it, and that causes us to go left. Then, in order to go to hit A, we have to move right, up, right, and then hit A. Yep, that caused it to hit A. Somewhere we get off here. Somewhere we do something wrong. Let me go left and press A, which causes us to hit the up button. Right and press A. Okay. All right. We need better debugging here. It's gonna be a lot. What is happening here? Oh, I can't put echoes in here, or else they get pulled into the output. I have to write it to standard error. That's why it took 8,000 years to run. Okay. What we can do now is, because we know the problem was here. It happened sooner. In order to go from A to left on the directional pad, we have to press down, left, left. That's correct. In order to go from left to A on the directional pad, we have to press right, up, right. Fine. In order to go from A to up, we just have to go left. In order to go from up to A, we just have to go right. In order to go from A to up, we just have to press left. Is this our problem? Did we return back to A when we didn't want to? Yeah, because in order to do this, no. Why didn't we? Yeah, no, this is fine. Oh, we committed. We committed after an empty thing. Remember, chat, no hints. That's right. That's right. I think we committed after an empty thing. Yeah, where we append this A. I don't think we want to do that unless steps is set. Yeah. If there's no steps, we don't need to do anything. Still suspect. Let me... One, two, two, 772. 1, 2, 6, 3, 8, 4. So now we're too low. Now we are too low. Let me think about this. No, we do. Yeah, if the person wants to go up, it does need to commit that. This is such a stupid thing to get hung up on. A to up to A to up to up. Yeah, but the one above it will need to actually press the A button. That gets me 131. Okay, both numbers are wrong. So we're not slightly faster, we're not slightly slower, we're just a little bit off. But we're going in a really good direction here. Yo, what's up, man? Welcome. We're doing Advent of Code puzzle challenges. so we need to find, what we have to do is we have to find the shortest one that breaks. And we know something here breaks. Calculate steps. All right. CP part 1 to calculate steps. We're going to do the same thing. We're going to make a nice little tool for us to use. So now we can run calculate steps, directional, this, and it will break it into that. Okay, cool. So now we can go to part 1, and we can just get rid of this. Dude, that's Vim. It's cool. That's right. I do all my programming in Vim. We got the terminal. We got a web browser. What else do we need? So this is wrong, right? This is incorrect. Because what it should be is this. Vim master race. Yo, that's so right, Roy. Nailed it. I'm just going to save this as good. Every time we run the command good, it's going to print that. So we should get... Oh, it's going to be unquoted. That's really funny. What is the quoting error here? Does it not like the redirects being part of it? It might not actually like that. Because it's trying to execute as a command. I'm dumb. Ignore me. There we go. So now we have that. When we run our command, calculate steps, we get that. And we should get that. Yeah, okay, so for some reason, it goes down here and presses A. We go left and we press A twice. Why does it go down and why did we go left? We can figure this out by reconstructing the string here. Where did this just end up with a single going left and then nothing? Where did we go left and then nothing? Left and then nothing. In order to go from A to up, we went left. Well, that's correct. Something's not right here. So yeah, we're committing something when it shouldn't be committed. In order to go from A to left, we have to press down, left, left, and then A. That will actually push the button. Makes sense. Where was the one that gave us an issue? A to up. Yeah, you press left and then you press A. What is wrong? Yeah, we went left here, and then it hit it twice to go from A to up, up. But this thing went down. Okay, we start here. We go down, left, left, down, left, left. We're here, and we press A. So that causes us to go left 1. Which is good because that's the first move we want to make. We want to go left 1. That makes sense. No, I believe there's multiple correct answers, but when we commit it is different. So there's something I don't like here. Like, the good example went down and then committed that. I went left and then committed it twice. And the twice commit is here. So we're doing this, like, commit here. That doesn't make any sense. I mean, you are right. You are right about the multiple answer, but I think we diverged at this. No, you're right. You're right. I'm trying to think of when we diverged. Because, yeah, a divergence at a step before this will create a way different thing. And actually, yeah, this is where the divergence is, and this is where it would be different. Yeah. What are you trying to solve? These are coding puzzles. I'm writing it in Bash. The coding puzzle is called Advent of Code. I'm on day 21 of 2024. Split answers. No, I don't think that's a hint. You're just telling me how to debug this. Split answers by spaces on each iteration. It would help to figure it out. I was thinking something similar like that to figure out like this answer, this set of steps came because of this step above it. So you can see how the tree kind of comes together. Yeah, I think that'd be useful. But I think that would be useful to have. I don't think that's my problem right now. My problem is I can't vocalize what it is, but I have like this hunch, which sounds really stupid, but like I'm operating off of a hunch right now. Yeah, there's just something not right in the way that I am committing them. Yeah, so according to the correct example here, what are we doing here? What's happening here? Kind of want I don't want to here's what I've been doing, by the way. I realized I wasn't sharing this. I don't want to do this. It's going to be a lot of work, but I kind of want to just visualize this. I want to write a program where I can just feed it a string like this, and it would just visualize on a numeric keypad the moves it took. Like it's too much, but like this is one of those problems where I feel like visualizing it would make it very clear what the issue is. I'm just spot checking this and like it looks fine. I made another program to check correctness of generated sequences. Yeah, I think I might do something like that. We'll see if that happens. Here's something I'm curious about. If we run part 1, calculate steps, numeric, this. Yep, so this will get you there. How many times does A appear in this, in the final output? The final output's just all the way to the bottom. grep-c, A. That is incorrect that it shows up one time. Yeah, it shows up 4 times. I can see that. You have to do grep-oa. Yeah. 4. Okay, so it shows up 4 times. So now, if we take this and we run our... Did I just create a bunch of files named A? No, I didn't. If we run this on this, how many times does A show up? 12. And if we take this final thing and blow it up into its final form, it shows up 28 times, as opposed to Eric's solution, which showed up 28 times. We are committing the exact same number of steps, we're just committing 2 extra steps. That's so fascinating that we are doing that. These are the buttons that we press on the controller. We press down right A. They press left down A. Or we press down left A. Okay. We're doing extraneous movement. How many times does Eric double commit a number? 1, 2, and then a triple commit. We have 1, 2, and a triple commit. All right, I have an idea. Here's what we're gonna do. We're going to make a visualizer script. I said we weren't going to do it, but we're going to do it. Yeah, CP solver to visualizer. RM visualize, Vim visualizer. Cool, so this thing reads in the grid. This does a solve maze, we don't want that. Read in the grid, whatever grid we give it. And then we give it a set of instructions to play through. So for instructions equal $1 for I equals 0, I less than len I plus plus do instruction equals $1. Nope. Instructions at I for 1. We need to calculate the starting location. So the starting location is always an A. So now that we're down here, we can do x equals start x, y equals start y. Let's call this cur. And then we print grid. We're going to color them. That's what we're going to do here. Let's do background color, actually. If we're hovering over it, then we color it red. Sure. And we know all these moves are valid, so we don't have to do any bounds checking. The double square brackets are for testing things. So like if something's a file, like, you know, if -f whatever or -e whatever, things like that. This is specifically for math. So arithmetic expressions. So I can say like x less than 5. You can't do that without putting $signs in front of them if you're using double square bracket. So double parentheses is just specifically for math. So if I run visualizer, read in the numeric keypad, and then we give it a whole bunch of instructions to run, like the good instructions on the numeric keypad from Eric. I have to... let's make my life easier. Cat numeric keypad pipe into visualize and then give it this. Oh, something's happening here. Okay, we like clearly walked off, right? Oh, because it's not numeric. This is running on a controller. The numeric's only the first one. This is a directional. This is really hard to understand what's happening here. Okay, so what's happening here is ridiculous. All right, ugly, but we're doing it. Okay. Okay, I'm just visualizing this, but like, I don't know what this gets me. So this is Eric's solution, and this one's fine. It's my solution that's the bad one, which is this one. So something about this solution is bad. I don't know what this gets me. This doesn't get me anything. All right, so in order to type this into a numeric keypad, you have to start at the A, and we move it left up, which gets us a 2. We hit enter. Wait, no, we hit left and A, yeah. Then we hit up and A, which hits 2. Up, right A, which hits 9. And then down, down A, which hits A. Yeah, that seems right. And then in order to hit these on a directional keypad, we'd have to hit down, left, A, which will hit the left one. Hit right up right to hit A. In order to hit this one, we have to hit left A. That sounds right. Then to hit A, we have to go back, right A. Then we'd hit left A to go back to up. Hit A on its own to hit up again. Right down A to hit the right arrow. Up A to hit A. Down left A to hit the down arrow. A again. And then up right A. I mean, that gets us there. And Eric's solution is this, which is the same length, okay? It's just when we turn this into its final form that we get this weird thing that's just slightly too long. So in order to hit down, we'd have to hit down left A, which makes sense. In order to hit left, we have to hit left A to get there, and then hit A again to hit it twice. Wait, hold on. Hold on. In order to hit down, we have to hit down left A. That makes sense. In order to hit left, we have to go left and then hit A. In order to hit left again, we just hit A again because we're already there. In order to hit A, we have to go up right A, not up right up A. This is wrong. Okay. No, that was to hit left. No, that's right. That's right, that's right. Yeah, no, this is right. This is a good sequence from Eric. Oh my god. This is a good sequence from us, right? Oh, that's frustrating. I don't understand how these are wrong. I guess I could just take one of Eric's correct solutions and try to break it down. Nah, I'm still even using mine thing, so it's not gonna work. That's 68, that's right. Okay, so if I use Eric's solution for the second one, then it's right. But if I use mine, then mine's wrong. Okay. So my second thing is wrong. 13, and his I think is also that. Okay. What is his solution here? His solution is 29. What is my solution? Okay. Mine's also 29. Okay, but mine just breaks wrong. If I use my solution, if I feed in my solution that I've generated using my algorithm, I get 71. But if I feed in his solution, I get 69. Okay, so something about my solution is not ideal. Something about this algorithm is not great. He went right, up, up, and I went up, up, right. That is the only difference. And he even says specifically in his examples that that one is valid. Because I went up, up, right, and It's the exact same thing. But somewhere along the way, I'm generating 2 extra steps that he is not making. But only with my version of events, not with his version of events. I went up, right. I went up, right, up. He went up, right. I do not understand. All right, let's think. Let's think about this. Something I'm doing here is just not efficient. All right, in order to go down, left, left, A, we have to go to the down arrow, we go to left arrow, hit the left arrow again, and then to go to A, we get here. We both hit this. I move twice, and he just hits A again. I get it. I see the problem. I see the problem. I took the shortest path, which could be, you know, left, left, up, up, left, or left, up, left. All 3 of those paths are the same, but when it comes time to program into a computer, if we have to go left to up and then up back to left, there's a cost with that. There's absolutely a cost with that. We want to minimize the amount of turns we do. We want to keep going the straight path if we possibly could. That is what we want to do. It is our solver logic that needs to be slightly changed. That is what we need to do here. We need to prioritize paths that don't go off the beaten path, that just continue forward. Which means moves in the same direction that we are moving. And a way we can do that is right here. In our solver, we just prioritize north. We shouldn't do that. We should move the one first that is in the next direction that we would be going. And we should just do that first. Try to move in the cheapest location first. I think this will do it. I could go through and clean up this code to do it. I don't know. Something here. So the location that we are moving in is not anywhere. Oh, we appended to the end of the string called moves. That's what we did. Yeah, that's what we do. So we can get the last item of that string. That's how we can do it. Yo, what's up? How you doing, man? Howdy, bashers. I love it. If we're moving to the right, then we want to prioritize going there. By doing one of these. Okay. Okay, I think that makes sense. We're on part 1. How's that? How does solver work? I don't even remember. Okay. So this should prioritize. Yeah. Okay. One two seven 900. 126384 it should be. So not quite. We got 68 though here. That's big. We have 60 here. That's correct. We have 68 here. That's correct. We have 64 here. That's correct. And we have 68 here. That is incorrect. The last one is incorrect. We somehow get 68 when we should be getting 64. Yes, I made sure that I'm not over an empty spot. The way I did it was I treated them like mazes that I solved. I don't remember what I called anything. Numeric keypad.text. I put a pound sign there, and then I just treated it like collision with the maze. So I never go over a blank spot. What sociopath stores data this way? That's what I want to know. I don't know what you mean. All right, so the last one is causing issues. The last one is 379A. and we get 69, which means there's 68 characters there, when we should be getting 64. Okay, so we're doing something, you know, not great. How are we doing that? In order to calculate steps, we do this, and it tells us to make these steps. Up, up, left to left. I'm just looking to make sure these steps are efficient. And by that, I mean there's no like up, left, up, or, you know, X, Y, X. And so far, they all look pretty efficient to me. But I don't know if we can test efficiency in a vacuum. That's the part I'm concerned about. Can you be efficient in a vacuum? Or do we need to like look at the steps before it? I do not understand this. Now why is this one inefficient? Now, according to Eric's good solution, it looks like that. So where I have this long thing, he has just this. He has left on left A, we both do the same thing. Up, up, right A, we both do the same thing. Down A, we both do the same thing. Let me just take these two strings. Okay, where do we diverge? Here's where we diverge. Oh, but then I only do one move to get back. It takes him 3 moves to get there, and then 3 moves to get here. No, it takes me moves. Hold on. I'm just going to put a space where we diverge. No, I know it's earlier. I know that divergence is here, but this doesn't matter. I want to see when we diverge and how long it takes us to press the A button, because if he's pressing the A button before me, he's doing something smarter than I am. Yeah, because, like, look. mean, I know he's doing a different code. Okay, maybe it matters. I don't know. But he's doing a different code than I am, obviously. There's got to be some way to generate a code that's more efficient. I can't see what his intermediate codes are for this one. I can only see for the ones before it. I just don't understand why mine would take so long. And his can be done so much faster. I almost want to write another piece of code that goes backwards. Like I have that visualizer. No, I don't want any hint yet. Nope. Thank you, though. I'm making a script called reverse. Okay. Okay, I want to see if this works. If I do my calculate steps numeric pad of 379A, these are the steps I would have to take on a numeric pad to type that in. If I were to do a reverse numeric of this, I call it reverse, it means just basically play it through. Nothing will happen because I have to read in something. Oh, because it's reading in from standard in. That's annoying. I understand why. Whatever. Okay, so now we can go backwards. So if I were to take my code that I generated for part 1 and walk my way backwards with it, I get this. Now if we were to walk this backwards, we get this. And now if we were to walk this backwards on a numeric keyboard, we would get 379A. Okay, so what I have is valid, it's just not the shortest. So now if we take what Eric has, we can actually walk it backwards and get some insight into how he generated a better code than I did. Okay. So he did left, left, up, up. I did up, up, left, left. And the reason I did that is because I kept going in the up direction. Because that was the direction we had previously gone to get to the A button. He seemed to bias something else. I wonder if I should be biasing the direction of like the A button. Oh my god, yeah, wait a minute, hold on, because everything has to reset back to the A button. So I should probably be trying to move that way last. Let me think about that. Everything needs to pull towards the A button. Okay, hold on. So I did this. I love the emojis. Yeah. Basically, it's expensive to change directions. If we can just keep going in the same direction, it's ideal. We moved up and hit the A button, which caused us to press. I'm losing it. Hold on. That's the only difference is these. But that had a giant cascading effect. How am I going to do this? Let me think. I'm gonna take a real quick break. I'm gonna grab something to drink. I'll be right back. Alright, what's up? I'm back. Alright, no one get excited. There's nothing fun in these solo cups. It's literally a protein shake. This is how I get my macros in, so I can stay in my calorie deficit and lose some weight. Hell yeah, Roy. Yeah, Roy got excited, darn it. I promise, this is a double chocolate brownie milkshake, protein shake. Axe and Sledge brand, 230 calories, 20 something grams of protein. It's awesome. This is going to fill me up for the rest of the night. Dude, I am so lost by this. I may have to ask for that hint soon, but I'm close. Like, I can feel it. I'm close. I'm so close. I just need to figure out there's a way to optimize these solutions based on maintaining some fact. And maybe that fact's going in the same direction or going towards the A button. There's something here. Yeah, I'm close. I can feel that I'm close. I just need to come up with some sort of bias for this so it chooses the best possible path that, when we expand the path, it will be optimal. You're going great. Thank you. Thank you. You'll be mad at yourself if you ask for a hint now. All right. No hints. We're here. I'm at the finish line. I just gotta cross it. I was gonna knock out some cookies and cream protein. Dude, do it, man. Oh my god. I love it. I love it. My hands are so cold. It's just so cold here. That's what it is. How cold is it outside? It's gotta be below freezing, right? Let's see. Oh yeah, 23 degrees Fahrenheit. Let's go. All right. So, I have to remember where we were. Here's what we're going to do. We're going to write some stuff down. Here's Eric's solution. I'm going to reverse it. I like this methodology of writing small little reusable utilities. If only there was some philosophy named about it and operating systems built based off that philosophy. Oh, I love Unix so much. So here is Eric's solution. We have good, and we have mine. Brutalism. Talk about Unix, bro. And not the Game of Thrones version of Unix. Deontology. That's what I'm talking about. I'm talking about the categorical imperative and deontological frameworks for understanding the world. Thank you, Kant. A rules-based system for understanding all that is existence. All right, what are we doing here? Man, you get one little direction wrong and suddenly the effects cascade beautifully. Okay. So his solution biased left. My solution biased the same direction we had been going in. Why did he want to go left? In order to press up using a directional pad, in order to press 3, we had to go up and then A. So we had to tell it to go up an A. And then we had to tell it to go up, left to go to 7. Whereas his solution told it to go left to left, up, up. I wonder if it's a distance to the A button thing. Like hitting left on the control pad takes a lot of work. It takes a while to get there. Yeah, it's a heavyweight thing to get to left. Oh god, this sucks. All right. These emojis are wild. Yeah, I'm trying to think, because like we pressed up, up, left, left. Yeah, we pressed up, up, and then we pressed left. So I have to imagine a hand. We moved the up button, we pressed it, went all the way left button, pressed it, and then had to go all the way back. Instead, it makes sense to go all the way left one, come back to the A one, come back to this, because every small movement we make is a series of bigger movements. So we have to make... I don't know how to express this, but I feel like... I almost had it. I feel like we need to score them. I'm just thinking out loud. I might not go with the solution. But like the A button is our anchor. These have a point. These have a score of 1. And this has a score of 2. It takes more work to get here. And that might not even be true. This might actually have a high score because it revolves a diagonal. This might actually have a score of 2. And this might have a score of 3. I don't know yet. But the distance from A definitely matters. I just don't know how. All right. Time to wash that down with a Dr. Pepper Zero, dude. I am the pinnacle of health. I know Roy understands this life. Yeah, because if we go up, up, left, left, we have to press AA, down, left, AA, right, right, up. This results in moving the arm 3 times before we commit. No, Eric's code moves it 3 times, then commits. Yeah, I don't think it's the number of times to commit. I'm not sure. Is that a Torbjorn emoji? That's awesome. Dude, it's so true, man. Eric's really good at obfuscating, like I would never think that the difference between these two and these two would matter, but he's like good at... Eric's really good at like hiding the important stuff in things that aren't important. Like this could have easily not have mattered. I could imagine a puzzle where I got a different solution than he got here and it would actually not matter. So as a result, I have to try and find out what's important and what's not important. So instead of thinking of the best possible way of getting there, I could make a list of all possible ways to get there. And then I could pick from that list which one is best for the given scenario. How do I determine that? I don't know yet. But I have to think about that. I have to think about which one is best for a robot arm moving. Oh, maybe that's it. Hold on. Because in this scenario, this path is bad, and this path is good. In fact, can we just isolate this to like up, up, left, left, A? Will that isolate the problem? Calculate steps, directional, up, up, left, left, A. Is that, which results in that. And then if we do that, we get this. And then if we did left, left, up, up, A, we get this instead, which results in this. Oh yeah, we can. This, yeah, this absolutely, this is a big difference. Oh, sorry, you're looking at the wrong screen. My bad, my bad. My apologies. Here's what I did. I mean, you can kind of see what I did. I'll just redo it. Yeah, sorry, my bad. I sometimes forget to swatch over. I need to write a little script that when I give a window focus, it just tells OBS to take over. And I probably will do that in the future. But let's see. So if we calculate steps for up, up, left, left, A. I can see why the Konami code is relevant here. Then we get this. If we do that same process for left, left, up, up, A, we get this code. Now this code looks similar. I am a bad streamer. That's 100% accurate. But look at this. This code is significantly better once we expand it upwards. How could we have known that? Now there is an implicit A here, so going up twice and left twice. Wait, isn't this a directional pad one? Is that even valid to go up, up? Up, up on a directional pad? Do we just go out of bounds? Let me see something actually. I want to see if I can get something simpler here. Oh boy. That is significant. That is actually significant. The way that it expands upwards. Oh man. Matthew, I hate that you suggested in that chat. I don't hate that you suggested it. I think it's fine. You're throwing out ideas. That was the idea I was coming up with. That was where my brain was going. I was literally going to say next, if I can come up with a very, very small solution that when I run it through this, I can score it. Because that's what I was trying to do. I was trying to come up with scores. Now I'm realizing it's way simpler than I'm making it. I have every possible solution. Now I can just calculate what it looks like when I expand it using my calculate steps tool, and I can take the one that is the cheapest. I just don't know about cascading effects of this. Just because this one is... Hear me out. I think I'm over-engineering this. Just because this one is cheaper than this one, couldn't you imagine a future where this expands into 80 characters and this expands into 70 characters? I could imagine that. I'm not saying that's happening. I'm not even saying it's possible. I'm just saying I could imagine it doing something like that. And then I think about, like, how much that would suck. Because if that could happen, that sucks. I don't think it's possible. Because we're basically just looking at possibilities like this. Dark Space cannot imagine it. Okay, good. Love your thought process. I love how you just broke that down. It took me way longer to figure this out. It's so funny. I'm gonna go on a little tangent here. I've been complimented before on my thought process, and I love it. I thank everyone who compliments me on it. But it's so funny because in my mind, my thought process is extraordinarily slow and methodical. This is how I approach problems. I have hunches. I have, things that I want to try out. I've just learned to recognize them for what they are. I'm like, hey, this is a hunch. I'm going off a hunch. Or I'm going to rewrite this. I know it's not going to work, but I have to do it because sometimes when I get paralyzed by code, I know it's bad. So I've learned how I work. But yeah, it's so funny because in my mind, my thought process is extremely slow and extremely verbose. But when I get the, as we say in racing, slow is fast. No, I 1000% believe in that. I won't imagine it. I am a big subscriber of that notion of, you know, slow becomes smooth, smooth becomes fast. Like, that's how I learned piano. So it's the same thing. So yeah, I do ascribe to that. Yeah, this is a wild thing. So I think I'm going to go with that solution for now. The generate all possible solutions. Don't prioritize this one. I don't think I need this logic here. I can try them all. And we're doing bread we're doing bread first search. So we should get all of them. We can get all of them that have the same number of moves. Bread first search. I hate it. Yes. We return from this function. Instead, we should just continue from this function, which won't push new things onto it. Yeah, here we go. I have an idea. Oh, okay. Bread first search. I like that. I think my hint will just push you over the edge. It's also more of some guiding questions than an explicit hint. Let's see. Give me a second. Let me implement this and see how I feel. Because once we get here, we have a possible solution. Let's do this. Declare, or I don't know, local solutions. Then we can store the solutions here. Oh, we have the S key in the moves. No, that will never change. That'll never change. Yeah. Find the optimal solution, cache it. Okay, so this is the code we have to modify right there. So once we get here, we don't return, we continue, and we do solutions plus equal moves. So we can do something like echo found solutions. Okay, now we can do this, and this will do solver. Let's do, what's the smaller one? The directions. I'm just going to do this so it doesn't break. What's breaking? Oh. Yeah, I can't do that. I overwrote it. Possible. Let's just call it that. Bread first search would be another good t-shirt. I like that idea. Oh my god. I should talk to Bad Cop about it, because I'm pretty sure I say it because she said it. So I should ask her if she wants to go in on a shirt design with me. It'd be kind of dope. Okay. Yeah, okay. So some of these are finding multiple solutions. That's good. That's what we want. Yes, it should only ever have two solutions for the... I'm staring at the control on the other monitor. The directional keypad, and I'm like, it should only ever have two. So now that we have the two possible solutions, find the optimal solution for try in possible, do, done. What was our script? Was it calculate steps? Yeah. I'm thinking. We need to know what kind of we need to know what type of thing we're looking at. Yeah, our solver needs to know the type. I've already written that logic. Let's go ahead and steal it. Okay, now where we find the optimal solution, we have to calculate steps of the type of the trie, and then we have to keep the lowest one of the length of it. Okay. Is there an easy way to do this? Without higher level data structures, it just gets kind of annoying to fumble around with this data. Just trying to think of fun, easy ways to do this. Local moves min equals, let's say it expands to 9999999. If len is less than min, then min equals len, and moves equal try. Cool. Now we have the optimal solution. Okay. So now let's rerun that solver. It's not going to work because we have to say solver D for directional. Okay. So we found two solutions, and we're keeping this solution with length 3. What are these? What did I print out there? Am I crazy? What's going on? Oh, that was the minimum number of steps I expanded to. Right. I'm right. I'm just printing out the wrong thing. Echo trying len. Okay. Found one solution, found two solutions, trying 5 and trying 7, and we should have kept the one with 5. This one had 4 and this one had 7. We kept the one with 4. Oh my god. Okay. Okay. Oh my god. Okay. Okay. So this is for the directional. And then this is for the numeric. Okay. I'm just going to copy that to my clipboard. And then numeric steps. Not the most elegant, but here we are. 127,900. 126,384. Okay, it's still wrong. And it's still the same problem. But we could go through this. kind of better understand it. What the hell was that? I don't know. Weird noise outside. This one is still giving me a problem. We still try the up, up, left, left solution. Why are we trying that one? That's not what I wanted. Yeah, we shouldn't be doing that. We should be keeping the one with the shortest ones. Yeah, it had to work. I don't know if it had to work. But there's definitely something. There's something that I'm just doing wrong, and I'll figure it out. Yeah, we're still going. It's still choosing to go the wrong way. Yeah, it's still generating the long movements. It is. I don't know why it is, but it is. Because what it should have done is it should have looked that generating it from 3 to 7. Yeah, this should be left, left, up, up, A. So the question is, let's make our life easier. Let's find and replace a space with a new line. I think that's valid bash, so I think this is okay to look at. If we wanted to jump from 3 to 7, it wants us to go up, up, left, left to do that. And that's wrong. We should be going left, left, up, up. I think so. No, we should be going up, up, left, left. It's cheaper. They're the same. I don't know. Dude, I don't know. Let's work on the solver. All right, we're gonna literally just check these manually, 3 and 7. It wants me to go up, up, left, left. Well, I guess it doesn't matter, right? We determined that these are the same. Which one's broke it? I don't. I'm blanking now. What was I doing that broke it? Okay, so that one's clearly not good. This one's, I'm losing my mind here. Alright, so it picked, let's just pick them at random. It picked this one. Good job, algorithm. You picked correctly. It picked that one. It picked correctly. It's picking the correct ones. How high up does it need to check? Do I need to check the steps up more a little bit? I don't know what I'm doing wrong. All right, it thinks this is the best movement. Okay. Well, wait a minute. Do I have a chicken and the egg scenario going on here? I used the cache data to build the cache data, didn't I? Calculate steps is a lie. Right? Calculate steps uses steps required, which looks in the cache. That can't be right. But then I rebuilt the cache. Can I just write out the cache again? I think I used the cache to build the cache. I don't think this is right. Yeah, I don't something. I'm not doing something right here because I'm in a chicken the egg situation. I'm using the cache to create the cache. That can't be right. Um, I use the stones to destroy the stones. Exactly. Yeah, this is not right. I need to just rethink this. I'm still on to something. I'm still on to something with this, but I need to score these. Dude, I'm brains fried. All right. I have all the possible solutions that will work. I need to figure out which one is best. The way I figure out which one is best is by figuring out the solutions that come above it. How do I do that? Because I haven't calculated them yet. Let me think about this. I don't understand. I can cache every single possible solution for every single thing. I don't know how to write this in code. I think I'm okay. I think I'm okay because even if I don't quite know the path I'm going to take, I know the cost of it at the immediate without doing any sort of indirection yet. So like if I'm going to expand a pattern, I know that it'll expand into like a 3 cost pattern, a 5 cost pattern. I don't need to know what those directions are or what those will expand into, but I know what they will cost. been 3.5 hours. Are you okay? I'm good. I'm chilling. Yeah. I'm just trying to think for this cache. I might have to do like 2 passes. I'm mixing implementation and theory, but like. Nah, I had a good idea. I need to be reminded. No, not right now. Not right now. I'm still in it. I'm still in it. Is my logic broken? Something's not right. Why would these two are not valid? Why didn't I stop once I got to a higher length? this isn't this logic just doesn't work if I read the cache to solve it. Like that there's no way that could work. It's part 1 still. Yeah. There's no way this works, right? Oh, that worked. Okay. In order to figure out if a move is good, we need to figure out what the robot above it would do to execute that move. And the way we've been doing that is by figuring out which moves are good based on just some bogus criterion. I don't know how to translate that. I don't know how to say, here's a move, make the robot execute it without yet knowing what the best move is. Like, I have this weird chicken and egg scenario. I don't know what the robot above should do until I figure out what the best move is, but the best move depends on that robot. I've gotten myself into a really sticky situation I don't quite understand how to get out of. I think I need to store cost. I think I need to do 2 passes. I think I need to store all possible ones. That's funny about Stowe. Yeah. I think it's a little bit ahead of my script, which is really funny. That's funny. Alright, so we make a string called possible. We append all the moves to it. So it's basically like an array. We set this equal to possible. We set this equal to possible. And then we what do I use here? Okay, we never use the, okay. We only need to cache this. We cache all of them. So then we have a score. We have solutions. Let's make scores. This isn't right. This isn't right. Not score, winning moves. Then we optimize it. So we found all of them. Now we need to go through every single one and we need to optimize the solution. For key in solutions, do done. Value equals solutions at key. Okay. Read dash r a possible from the value. For p in possible, do done. These are all the move sets. Dude, I do not understand this at all. I'm so lost. Oh my god, what's happening? It's a maze, you're supposed to be lost. Huh. I do not know what I'm trying to do right now. Yeah, so like this one has two solutions. I have to figure out which one's good. We keep a score. in order to know which one's better. Nope, I have no idea how to do this. I don't know. You want to hit me with the hint? Go for it. I think it's time. I cannot figure this out. I am in a chicken and the egg situation where like I'm trying to cache something that I don't have. Whatever. I'm done talking. Yeah, I'm ready if you got a hint for me, Dark Space. I don't even know what the score is anymore, dude. I'm lost. To get from A to left. To get from A to left, which is better and why? Left, down, left. Down, left, left. To get from up to right. Down, right, or right, down. To get from... None of these are trick questions. Gotcha. To get from... To get from A to V, left down or down left. If I go left down, I have no idea. I have to really think about this. If I go left down, the robot above me had to press left and then A, then down, and then A. And in order to go down here, if I had to go down left, I have no idea. My brain's broken. To get from A to V, obviously there's two moves I could take. I can go left down. That takes me 2 moves, but the robot above me, the robot controlling me in this example, has to go all the way down to left and then press it, which means the robot above him has to go all the way. It doesn't matter. And then has to go down and press it. Has to go here, back, down, back. Otherwise, it has to go down, back, left, back. I don't know. It seems like it's the same. I know it's not the same, but I don't know. I don't understand this. No, I don't want a more explicit hit. Thank you, but no. I get the A to left example. If I go left, down, left, that sucks. I understand that sucks because the robot above me has to go all the way to the left, hit enter, come back, go down, hit enter, hit A, go all the way left and hit A again. But if we can double up those moves, it's better to double up the moves because then I can just hit A simply. But I don't think it's just that was the optimization I did before, which was just keep them going in the same direction. But I think it's more than that. So to get from up to right, the robot above me has to go to down. I don't know. I do not understand this. I don't understand what I'm missing. I think if I stopped streaming and came back to it, I'd figure it out, but I cannot get this right now. I think my brain is too fried. To get from A to left. Yeah. To get from A to left, it's clear to me that the better one is to go the same direction. To go the same direction multiple times, because the robot above me has to do way less work. It can just keep its hand over the A. We want the robot above me to have to do the least amount of movements. So if we're going from up to right, the robot above me has to either make me go down right or right down. No. If we're here and here. Oh, nothing's actually going through my brain right now. Give me a second. I am back. I apologize, everyone. I got very frustrated. It's not even just streaming, it's just life stuff in general. This past couple of days have been really good, but really stressful. A lot of fun, just really busy. And I was looking forward to just having a night where I could just like stream and chill and get back into it, and it ended up being a frustrating puzzle. But I still am having fun. I like these puzzles. I think it's super fun. I love racking my brain and coming up with the answer at the end. Hopefully, I know it's probably not as entertaining for people when I'm getting really frustrated and stuff, and I'm sorry about that. Like, that sucks. I understand that. But I do enjoy it. You may want to cut a few seconds before you went on mute from the stream recording. Yeah, I need to look up on YouTube if that's possible. I never explicitly said that I would be like, family friendly or not swear, but I do try to do that. Like, I do try to do that, but I mean, you guys saw the raw coding reaction. Like, that's how it happens, Oh, man. But, yeah. Oh, man. Let's see. May I ask you a favor? Could you make a story on Instagram on the day you were going to make a stream? Because of time zone, it's hard to stay awake to figure out. If not, that's okay. And now I need to go. Yeah, have a good night, Tablet Lenovo. And yes, I will start doing that. I'll start making stories and stuff on Instagram. In fact, when I start streaming, you people who join in the moment I start streaming, if you want to remind me, like, yo, Dave, blast out in your socials that you're going live, like, shoot, like, let me know. I'll do that. 100% I will. We already knew it was going to steal your soul. All good. I know you got this. Yes, thank you. I appreciate it. What's that T:3? What are you talking about? Am I missing something? We didn't start with a piano this time, see? So there's no correlation is my point. Next to your heart message? I have no idea. Oh, on the overlay. I have no idea. It doesn't show up on my chat, so that was weird. But yeah, music interlude sounded like a great idea. I am zen now. I think I'm very close to solution. I think I have it basically down right here. My logic is when we cache the best possible solution, we have all the possible solutions, we just need to score what is the best one. Oh yeah, when you do a heart emoji, it just puts a T here. Let me try. How do I do one of those hearts? Okay, let's see if it happens when I do it. Yeah, it happens when I do it too. It's gotta be, was it Botrix? I think that's the name of the dual chat overlay thing I'm using, so I wonder if they have some weird thing with it. Oh, hell yeah. Love having a bot. That's sweet. Ah, man. I like that heart one better. All right. I think we can do this. If I look at your hint, I completely understand that if I wanted to go from A to left, that's a really hard span across the map, and it makes sense to go the continuous direction. But when I want to go something like A to V, I have two choices. I can go left down or down left. Those are my two choices. And you know what? I mean, we can just do it by hand, I guess. Let's do it by hand. If I wanted to go A to V, I can do left down or down left. These are my two choices. I'm not showing my terminal. So yeah, if we want to go A to V, we have two choices. We can go left down or down left. If we go left down, that means the robot above us who's starting at A has to move down left. I know the chicken and the egg scenario here. Down, left, A. Right, up, A. What's up, Ash? You're a little bit late to the party. How is it going? I got really frustrated. Then I ended up spilling my Dr. Pepper on my lap, and I got really frustrated. And then I had to go calm myself down, and we're all good. This puzzle has been trying. It is very difficult. It's really been very difficult. Wait. Hold on. Wait, I'm being stupid. It's not a Dr. Zevia. I don't drink that crap. That's garbage. Dr. Pepper 0. That's the way to do it. That's the cheat code. If I want to go left, then down, I start at A. Oh, my brain is breaking. Why can't I just do this? I have to move the thing to the left. Coke Zero's the go. Yeah. I'm a Pepsi guy myself, but the Zero variants have been amazing. Oh my god. I'm just trying to think of a path. If I want to go left, I have to move my cursor, down, left, and then hit A. And then I have to go right, up, and hit A to hit the A button. No. I'm losing it. I don't hit the... Man, what am I doing? Down, left to get to that button. Then I hit it. Then I go right and I hit it. As opposed to if I wanted to go down and then left, I'd have to go down, left A. Oh. I see. I want to it's proximity to A, I think. I want to bias the ones that are closer to A. Because then I don't have to backtrack. You know what I have to do? I'm thinking about each move independently. And what I have to do is I have to do like what package managers do with dependency graphs. I have to create a plan. I have to actually create a plan on how to execute this. I can't think of one move at a time. I have to think of all the steps in a move and then think about what order to visit them in so I can reduce the amount of backtracking I have to do. And distance from A seems like a really simple way of encapsulating that. I don't know if it fully encapsulates it, but it seems like a simple way to encapsulate it. So when I'm solving this and I have every possible solution, let's see. Yeah, when I have left V and I have left down and down left. I basically just want to rearrange them. Like, it sounds so silly. I'm trying to think of a simple way to do this. Like, I don't know. I don't know how to do this, but I have to come up with the possible steps. If I have A to left, then I want to go, I can do left, down, left, or I can do down, left. And obviously this bottom one is ideal. I don't know a way to write this, but like, I want all the lefts to be at the end. This one's ideal because I don't have to do any backtracking, and because the two moves are next to each other, like, my cursor's already where it needs to be. My cursor, my robot hand's already where it needs to be. I don't know how to express why this is ideal. It's ideal because I started close to A and I end as far away from it as possible. I don't want to end far away from it, but I end as far away as I have to end. Let me just think about this. I'm gonna come up with a key, and I don't know if this is true. If A equals 0, because it costs nothing to get there, then up is equal to 1 because it costs 1 move to get there. Right is equal to 1 because it costs 1 move to get there. V is equal to 2 because it costs 2 moves to get there. And left is equal to 3 because it costs 3 moves to get there. So I feel like I want to sort them in this order, where I want... Yeah, I want these guys to be... I want the top ones to be first list. Like, if we have to hit an A, like, it's got to be the first thing we hit. And we want them to be in this order. But the same would go for the... It's direction to A. It's distance to A. The same would go for the numeric pad, where A would be equal to 0, 0 is equal to 1, 3 is equal to 1, 2 is equal to 2, 6 is equal to 2... I mean, I could map this whole entire thing out. And then what do I do with this score? So, like, if we have this is the same as 3, 2, 3. And this one is 2, 3, 3. This one's preferred because it's in the sorted order. Is that enough? Is that why it's preferred? Is there something else I'm missing here? Because if this holds true, then left and down, left is 3, and down is 2, using my own key, and down is 2 and 3. This one would be ideal because it's in sorted order. I mean, it really could just be that. Oh, man. But is it just that it's in sorted order? Will I always get something in sorted order? Will I end up in something that's closer to sorted order than not sorted order? Oh, wait a minute. I'm worried about sorted order. I don't think I need to worry about sorted order. I don't know if this is real, but I could multiply them by their index and add them up and generate a score that way. So, like, this might be overkill, but like 2 times 2 plus 3 times 1 plus 3 times 0. That's bad. Basically, the number at the I position it is, or I plus 1 or whatever. And then I could add that up, and that would be like its final score. And the lowest score is the best one. I'm using tens places here. I'm using base 10. Which might not work for the keypad, because the keypad has 11 possible things. But no, it's distance, so it should, base 10 should fully encapsulate this. I'm just going to be wasted. It's not going to be as ideal as it could be. I could probably do the base that matches the whatever. I'm overcomplicating this. Yeah, because if this is true, then, like, you know, 9 plus 6 plus 3. And this one would be 6 plus 6 plus 3, which would equal 15. So this one has the lower score. So this one's better because it moves the lefts, these expensive operations, closer to the least significant side of it, which results in a lower score, and the lowest score wins. I could do something like that. I don't know. Let's just try it. I don't even care anymore. Let's just try it. Scorecard. Because this is this is going to be just distance to A. If we're doing the numeric keypad, then the scorecard is A equals 0, 0 equals 1, 3 equals 1, 2 equals 2, 6 equals 2, 1 equals 3, 5 equals 3, 9 equals 3, 4, 8 equals 4, 4 equals 4, 7 equals 5. This is... Come on. This is scuffed. I don't care anymore. I'll have to quote some of these just to make sure nothing breaks. I think this is valid syntax. Dude, this is like some Terrence Howard math. This is like, this reminds me of when I wrote that, what I thought was Minecraft circle logic until that, where you had to like rotate that cube to do the clipping section, until I was laying in bed that night and I remembered your chat message, Dark Space, where you said rotated cube, and then I pictured in my head, I was like, oh, yeah, that's what it was. It wasn't a circle. I didn't do anything fancy. I rotated a cube. That's actually what I did. In my mind, it was a circle, but like when I actually, like, I was like, oh, you're right. It is a rotated cube. That's exactly what it was. I don't know why I tend to overcomplicate these things. Dude, this math, this sucks. But here we are. All right, so now we know the scorecard. Now we can generate the score. We have all the possible things here. Generate the score and keep track of the lowest. Okay. Minimum equals 999999999, and that's what we'll do. I love when I just do 9999999. Like, it just shows just there's so many better ways to do this. Okay. So here's the thing. So calculate score. This will take a move set and a type. I mean, the type's only ever going to be... I'm confusing myself. Hold on. No, yeah, it's fine. This program only runs for a given type. Yeah, so we already have the scorecard. Right. I'm overcomplicating it. We already know what the scorecard is. Okay. Oh. I'm going to loop over this backwards. That's fine. We can loop over it forward, and we can set J. Equal to length. Yeah, we can just keep 2 counters. Let's grab the character. Got to grab the scorecard of that character. Yep. All right, so score plus equal. No, we gotta do it all math. Score plus equal n times c. Okay. If score is less than minimum, then final equals p, minimum equals score p. And then when we get down here, we're just going to write that back into the solutions at the key equals the final. Oh my God. Oh. Does it not like this? I actually don't know this. I think that's valid. It's not. It knows it's a... knows it's an associative array. Oh. This syntax is not valid for an associative array. That is how you do it. That was some neat Vim magic. Oh yeah, I'm recording a macro. You can record your keystrokes with Vim and then play back the exact keystroke. So as long as you write your keystrokes in a way where it'll like find the right spot in the line, you can do really magical stuff with it. Sorry, yeah, that totally probably looked like magic. Why is it a bad, what is a bad array subscript? Oh, because it's empty? Yeah, that'll do it. Not n times c, n times I. Please do a short on that one. I should. Yeah, dude, remind me. Like, send me a message on like Discord or something, or like, you know, at me or something in the server. I'll remember to do that, because yeah, I think that'd be cool. Hey, I think we're getting somewhere. Yeah, man, definitely. 131,946. That's too high, isn't it? Yeah, it should be 126. Okay. So we're back at the same problem, where this one is 70 when it should be 68. This one is 62 when it should be 60. This one is 70 when it should be 78. This one's 66, and this one's 70 when it should be 64. What the heck? Let's find where the bad stuff is. Because we know going from A to left is probably a big culprit. A to left. Down, left, left. Hey, that's right. That is correct. There's an issue with your logic. Cool. I realize you're saying that, and it's probably informed by my code, but I totally just interpreted that as like, I got the wrong answer. There's an issue with your logic. Like, yeah, obviously. Yeah, I'm not sure how sold I am on this scorecard thing. Calculate score, takes in the set of moves. The lowest score is what we want. Oh, I made this variable for a reason. J, not I. Still wrong. Yeah, it's all of them that are wrong. Okay. I made an incorrect assumption somewhere. Sick. Yeah. Yeah, I wasn't convinced that this was going to work. I'm worried that these scorecards, because it's static, it's only the distance to A. And the distance to A matters. But when you're jumping from a number to another number, who cares what the distance to A is? I care about the distance to something else. But I don't know I don't know what I'm saying. Yeah, I'm worried that I'm caring about the distance to A when I'm calculating like every possible solution. That seems kind of silly. I might want another hint, but right now I don't think so. Not this moment. What am I doing? From A to left, I have to go down, left, left. That makes perfect sense. What about from left to A? Yeah, look at this. Going from left to A. It's not great. I don't know why. Dude, if we're going from right to A, or left to A was what I was looking at. Yeah, this one's suspect. I don't know how to express that this is not good. Oh, yeah, it's not going to work because I have to generate a score for each one. Man, it's brutal. I'm losing my mind here. For some reason, it thinks that if you're going... Oh, no, right. I don't want right A. I want left A. Okay. It has to choose between these two. And it's using a score based on distance to A. Oh. And these have the same score. I don't know how to programmatically say, like, prefer this one. Like, I need it to have a good score, but I also need it to, like, prefer ones that are next to each other. But that seems like... It seems like there's a better way to do this. Kind of want to reach out to TR. Yeah. I want to squeeze them together, which will get rid of duplicates, and I want to take the least length ones. I don't even know how to do this. We're just gonna go. Oh. That might have worked. Well, that didn't quite work. Oh, I see the problem. One two seven 900. I think I've gotten that before. Yeah, 126 is what I want, not 127. I'm so close. 68 is right. 60 is right. 68 is right. 64 is right. This should be 68. Sorry, 64. This should be 64. That's right, Ash. Ash, you should be excited. I'm working on a new piano album. It's not... Hold on, it's not piano. It's not piano. It's ambient, so very piano, instrumental, atmospheric type of music. And I'm just finishing up, like, some of the final work on it. I'm hoping to release it in the next, like, month or so. Yeah, sleep music, exactly. So far, it's like 55 minutes long. It's 11 tracks. It's really cool. And one of them actually uses undercurrents as, like, the sample to get the really cool sound, so it's pretty neat. This is wrong. This is the issue right now. It thinks that this one is better when we know that it's not. But it puts left at the end, which I don't think is a safe assumption to make. Dude, I don't know, man. This one's breaking me, man. But, like, people said it would, so. Oh, you're right. Yeah, Eric went left, left, up, up. I went up, up, left, left. Yeah, they weren't joking. Yeah, they weren't joking on day 21. Check your notes. Let's take a look at my notes. Yeah, mine goes up, up, then left, left. Because I consider left, left to have a higher score. So I put it at the end. But Eric considers left, left to be the better thing to do here. Because... would the equation at the bottom of the screen prefer left, left? Oh, okay. Let's see. Good question. This is 3311. Yeah, so. Where am I getting this location right? let's just stick to the, okay. 4 times 3, 3 times 3, 2 times 1, 1 times 1, and then we add all those together. Twelve plus 9, 21, 23, 24. Yeah, so this one has the higher score. So according to my logic, I would prefer this one. And that's the one I'm choosing is this one. But this one is the one that starts with up, up is not good. Yeah. The one that starts with up, up is not good because that's what I've chose here. And it's not good. Eric chose left, left, up, up, and that one is good. So my equation is flawed. My logic doesn't make sense here. Okay. %90 of your logic is fine. You're just face planting the last step. Yeah, I don't know, man. Like, this is the better one. And this is the one that has a lower score. This is the better one. And now it has a higher score. Top one is a weird case. Ignore it. Yeah, that's tough. You know, one thing I think it was like, but I mean, this won't work. Oh my god. I could generate this score here. I'm not even using this score in like half the places where I define it. Let me rephrase. Why isn't left left V the best for that? Left left V. Or do you mean V left left or I mean left left V won't work because we'll go out of bounds. Like this, I mean that's just broken. You can't do it because you'll go out of bounds. Huh. Okay. Yeah, I don't know where to go from here. I have to like think in round trips. Like, if I'm going from 3 to 7, that means my robot has to go from 3 to 7 and then hit the A button. I don't know. I got nothing. What am I doing here? Oh. Probably. Just give me 1 second. The only thing I can think of is like I'll be honest. I have no idea what you're trying to hint at. The only thing I can think of is like I don't know. I got nothing. In order to go from 3 to 7, I have to make all these moves and then hit A. So I have to go to like moves and then go back to A, and I have to calculate which one would be the best. So like I'm here. I have to go here, here. I don't know. I'm just thinking out loud. Here, to go here, here, or here, here. So going to here, and then to here, and then all the way back is somehow worse than going here, here, and here. I got it. Yeah, give me the insight you're hitting at. Because it felt like I was close, but I have no idea. I'm so lost right now. I have too many ideas that I can't implement them. For your moves, do VS, left S, do lefts, then downs, then ups, or rights. Yeah, so bias the lefts first, then the downs, then upper rights. Doesn't matter. Prefer duplicate moves in a row above all else. Yeah. I have the duplicate part down. Somewhere. Yeah, I use TR to get the duplicates. It's a nice little trick. Yeah, I squeezed all them together and I looked for the smallest one, and that told me that they had the most duplicates. So I filtered for the duplicates first. And then I need to try to do the lefts. They're the most expensive. Do you want to try this real quick? It's not going to work, but I just want to try it. I don't care if it's named poorly. That's not right. I understand. I don't know why that's better. But you're right. I have it. I have it here. Like, do these, then these two at the same time. Like, I have the right scoring mechanism. So I understand that. I think my score logic was just backwards, and that out of bounds thing might have been throwing me off. Does this work? Still broken. Still doing that. Okay, this is ridiculous. I could manually change it. I could. You're right. Like, I absolutely could. And that's probably what I'm going to have to do. I just don't know why. Like, I don't know. I don't know why that's the case. Like, what I'm trying to figure out is why my scoring not working? Because, like, ups and lefts. Real quick. Ups and lefts. Yeah, we should be massively preferring lefts here. You know, it would be helpful. Hear me out, hear me out. This is a crazy idea. It would be helpful if my calculate score function returned the value that it generated instead of returning nothing, which bash will interpret as a 0 when treated arithmetically. So hear me out, hear me out. It could be useful for the whole scoring system to have worked this whole time. That could have been something that was useful. Now, don't get me wrong, we're still getting zeros everywhere, so I don't think it's quite working. Hear me out, hold my beer. You got it, man. That's exactly what I mean. Like, just... let me give you this crazy idea. If my code did what I thought it was doing from the beginning, we may have gotten somewhere. But I also think something's a little bit wonky here. So we're just gonna put some debugging here. Because we're just returning 0 a whole bunch of times. Like, that can't be right. No, okay. Yeah, implicit return sucks. No, don't get me wrong. Yeah, I agree. It's just Bash is so funny. It treated this like a little Unix program. So I was like, oh, you have no standard out? Cool. We'll set that variable equal to empty string. And that's great until I go to treat that variable as a number. Then Bash is like, yeah, that's a 0. Empty string, that's a 0. And I'm like, dude, it's none of this, man. Am I crazy? Okay, the score is always 0. Why is that the case? Yeah, am I crazy? This is a 2 times 1. Are you sure Bash isn't JavaScript and trench coat? Listen, I'm not sure of that. All right, well, it would help if n was set equal to something. Dude, am I crazy? What's going on here? Yeah, that's right. We're passing it here. It's being passed back to us. Something about this is just not happy. Yeah, okay. We're getting there. Are we using the wrong scorecard? Yeah, this is for the numerical one. And we're using like a scorecard like this. We should be using a directional scorecard. I don't know why. I can't think about this right now. Let's just try that. Those numbers look a lot better. Same problem. Dude, I'm fried, man. I'm absolutely fried. Let's do this. Okay. So now we need to prefer, because I've given up on scores because I cannot figure out my life. Prefer left, down, right, up. We're going to do it in that order. Left comes first. Down comes first. Down. Left, left? No. How about left, left, down? Wait, this could put us out of bounds, though. I'm not checking this. If we want to go from up to left, we have to go this way, otherwise we go out of bounds. If we want to go to A to left, down, left, left is the way to do it. That makes sense. This all seems right. It's going to be the next one that we have to care about. Okay. If we want to go from 2 to 7, we want to go left first. This is insane. What's happening here is insane. Yo. ARX Aaron, Arcs Aaron. Did you tell me how to pronounce your name? You did. I'm sorry if you did. Thank you for the $5 super chat in YouTube and the comment of for awesome persistence. Yo, I appreciate it because I feel like I'm going a little bit crazy here right now, but I'm way too stubborn to give up now. You just solved what took me hours to figure out. One of my paths went out of bounds. Oh my god. So you did not find a faster path like you said. That's really funny. Oh man, that's awful. Like, I mean, it's a puzzle. It's the nature of it, but still, that's kind of awful. Oh, I can't believe I'm doing this. What are the ones I have to care about? Left, down, and then right up are the same priority. Left, down. We have to go this way because otherwise we'll get out of bounds. I had a checker at the beginning, but I removed it partway through. Oh no. I just went back and finished day 6. Bloody thing had one edge case and the real input that took me hours to debug. That's terrible, dude. When it's just like one tiny little thing, it's the worst. Oh man, what line am I on? Line 30? Out of what? Oh, kill me. All right. Lock in, boys. Right, down. I don't remember now. Left, down, right up. Left, down, right up. That's the order we need to care about things. Left, down, right up. 4 to 0, that will go out of bounds. Okay. Up, up, or sorry, right, right, up for 4 to 9. Right up, that's fine. 4 to 8. We just went right up. Doesn't even matter. Up, up, down, down, left, right, BA. Listen. Yeah, 100%. I feel it. It has to do this or else it'll go out of bounds. 8 to 7. Up, 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 left, left. Yeah, that's right. Otherwise it'll go out of bounds. 8 to 4. Up, up, left, left. Yep, otherwise it'll go out of bounds. 8 of 5. Has to do this or else it'll go out of bounds. No. Left up for 8 of 5. This feels like such a janky solution. But I don't care. 8 of 8. It can go left first. I don't know why my score calculator didn't work for this, but it didn't. I should have thrown out collision detection, detected all possible paths, and then thrown them out later. Down, right, down? Yeah, no. Oh, you have to because of, yeah, because of the out of bounds. Left, down, right up. Left, down, right up. Six to 0 is down, left? No. Left, down. We're on line 62. We are halfway there. I'm glad I wrote it this way. Like, I can just say that much. Oh, what is this? 7 to A? Right, down. 7 to 0. We're... Seven to 2. Yeah, this is right. These are good. That has to do that or else it'll go out of bounds. 0 to 7. Up, left. Yeah, that's right. 0 to 6. Up, right. Doesn't matter. 0 to 5. Up, yeah. Up, left has to do it. Also goes out of bounds. Up, right. Doesn't matter if it which way it did it. Okay. Down, right. Down, left. No. Left, down. Bro, this is wild. Imagine if this doesn't work. Right up. That's fine. Left, down, right up. 9 to 2. Oh yeah, we should be moving left first. 9 to 0. We should be moving left first. Oh boy. 9 to 1. Oh yeah, we should be moving left first. It's right. I had the scoring logic like right, but I just couldn't get the code to work. Like I know the scoring would work. But this works. Thanks to manually editing it. CP I don't know which one I was even editing. Directional steps to directional steps dot safe. CP numeric steps to numeric steps dot safe. Now we won't lose it. Just a little human preprocessor. On the bright side, Dave's descent into insanity is a lot slower than mine. It was more fun to watch. I have a large tank of patience, but it can still be exhausted. I will give you my pass if this doesn't work, although bedtime is in a few minutes. Dude, that's fair, man. It's getting late. If it doesn't work, don't worry about it. I don't need paths that will brute force the answer. It's okay if I don't get the answer tonight. I mean this. If I run this and I don't get the answer tonight, it's okay. I want to revisit this. I think the score is something that can be messed with. Part 1. Real input. 197560. What was that? Did I get it? Did it log me out? Hold on, let me log back in. I think it logged me out. Okay, I just reset. I reset it with GitHub, so. Let's see. You ready? This sucks. Come on. Come on. This sucks. I mean, awesome. GG. We did it. Hell yeah. And Eric says if you get the right answer, you get the right answer. So, like, yeah, that's true. And I understand why it worked. I understand. Yo, Bad Cop, are you still here? Oh, my God. The living legend herself. Oh, my God. Incredible. What's up, Buddy's Pizza? How you doing? Oh, my God. Yo, thank you, everyone. Thank you, everyone. We nailed it. I'm going to read part 2. There's no guarantee I'm going to start part 2. I'm just going to be honest. We might have to do another stream for part 2. I semi-manually made my paths. Don't feel bad. Dude, I feel like... Here's my thought process. Forget the part about collision. Forget collision on purpose. Use that scoring thing that I came up with, the calculate score, but actually implement it correctly, where we actually correctly do it. And then... So... prefer squeezing it all together and getting the smallest one there, then calculate the score correctly, then filter out the ones that are out of bounds, and then re-roll if you have to, if you ended up with 0. I feel like that algorithm could work. Could work. Yo, Andre, thank you again for the thank you for the $5 super chat. Oh my God, I'm losing track of everything. I'm losing my mind over here. Oh my God. I said thank you again, not because you super chatted today, but you've super chatted in the past. Yo, I appreciate it. Oh my God. Thank you. That's super nice for the $5 super chat in YouTube. That's amazing. It'll be quick. You got it? I don't know about that. Here we go. Let's read part 2. Just as the missing historian is released, the historians realize that a second member of their search party has also been missing this entire time. A quick life form scan reveals the historian is also trapped in a locked area of the ship. Due to a variety of hazards, robots are once again dispatched, forming another chain of remote control keypads managing robotic arm-wielding robots. Oh my God. This time, many more robots are involved. In summary, there are the following keypads. 1 directional keypad that you are using, 25 directional keypads that robots are using, 1 numeric keypad on a door that a robot is using. Well, okay. I mean, this... Okay. This seems okay. Oh my God. Unironically, Bad Cop doesn't remember if you use a Lumos or Open Indiana. Can you answer this? Oh my God, is this a secret Bad Cop friend? Oh my God. I mean, I use all sorts of stuff. I use Illumos, which is the fork of Open Solaris after Sun Microsystems was purchased by Oracle. But Open Indiana is, think of the Linux kernel, and then you have like, you know, Debian, Ubuntu, I can't believe I just used that, Arch, Linux, all the different distributions. You have the kernel and the distributions. Illumos has distributions as well. You can think of them like that. Open Indiana is one of them. SmartOS is one of them. OmniOS is one of them. There's all sorts of ones like that. So I used Open Indiana in the past. Then I used SmartOS for a while, and now I switched to OmniOS, but they all use the Illumos kernel, so I have like all the same userland tools, just different package managers, different services that come up at boot, things like that. But it's all Illumos under the hood. I'm not using any Open Solaris. I don't bother with that. We're not really, I don't know what Oracle's doing. So Illumos completely branched away from Oracle. We have Open Solaris, so I mean, we have like native ZFS, dtrace, all that stuff. But don't get me wrong, I still virtualize Linux. So like when I need to use Linux for something, I use Void Linux typically. It's just a very simple Linux distribution that doesn't have systemd, which I find like overly confusing. I don't even know who that is. Also, yeah, thank you, Dark Space. You may have already left, but thank you. Yo, appreciate it, man. You've been super helpful during these. Big fan of ZFS. Use it on Debian Box. Good luck on the AOC. Yo, appreciate it. Yo, ZFS. Oh, man. I remember going to a Linux users group in Mountain View. when I lived in California. This would have been 2011, 2012. And they had like a war of the Unixes. So it was Linux users group, but they invited other people. So they had a person there that represented Inferno, which I believe was forked off of Plan 9. They had Brian Cantrell there representing Illumos. They had, oh God, I forget his name. It wasn't Alan Jude, but it was someone else doing FreeBSD, and they had someone else there representing Linux, and it was really cool. And they went around the room and asked them questions, and they were like, so, FreeBSD, what's the best file system? And they were like, oh, that's easy. Illumos already solved this problem. We just forked it, so it's ZFS. ZFS is the best file system. Like, I'm all for all the Unixes out there forking ZFS. Like, I mean, I don't want you to fork and go off into the woods and create your own thing, but like, dude, it's the best file system, man. Like, just real's got to recognize real. So for this part 2, this is just do it 25 times, right? Like, it's just do it a number of iterations. Like, this just seems like I'd switch a number out and I'm good, right? BSD seems like it copied a lot of Solaris' homework, and I mean that in a complimentary way. I think it absolutely did. And of course, vice versa. Like, definitely, oh my God, go install Illumos. Go like install OmniOS right now. It's the FreeBSD installer. Like, they just use it because it's great. It works. But I mean, why do you think FreeBSD has like dtrace and ZFS? It's awesome. Like, they share really great technologies. They have some, it's so funny. You know, this is human psychology. You know, when things are so close together, you notice the differences. And when things are so far apart, you notice the similarities. So like when things are just ever so slightly different, the contrasts really stick out. I feel that way about FreeBSD. When I look at them from an Illumos standpoint, I'm like, oh, this is different, this is different, this is different. And then when I look at Linux, I'm like, oh, we kind of have that in common. But really, like, Linux is so far off in its own world, and FreeBSD and Illumos are like siblings. I think Linux is like a cousin, and FreeBSD are siblings, and like, I don't know, Windows is that weird uncle that shouldn't come around. But yeah, I use Illumos and OpenIndiana as a distribution of Illumos. So good question, Buddy's Pizza. I will remember you as being Bad Cop's best friend. So yeah, I think I just like CP part 1 to part 2. I do want to figure out why. I know I'm not sharing. I do want to figure out why I can't generate these paths naturally. I feel like my scoring algorithm should be right. Windows, we don't talk about Windows. Yeah, I use it for playing StarCraft 2 and Fortnite, so I'm an adult. Hey, completely unrelated. Did you know Web MIDI exists? Just learned that today. I had no idea. I don't even know what that is. As I assume it's like MIDI on the web, but no, I didn't know that exists. That sounds pretty cool. There's some MIDI. All right, cool. No one look at this code. It's really bad. So we calculate the numeric code. Then we have to do 25. Problem is we're already doing 2 here, so I guess we'll just have to copy this and go from A to Z? No, A to Y, right? We're not going to use a for loop. We're just going to manually. We have A, we have B, we have C. I feel like if I copy and pasted this and made it go all the way down to Y, this is the kind of joke that Bad Cop would actually appreciate. But what's the loop way of doing this? There's got to be a loop way of doing this, right? For I equals 0, I less than 25, I plus plus. Let's hope I'm not off by 1. Then we can just do this. Done. And then change this to this. And that's it, right? Do they give us the... Oh, they don't even give us the answer to the example in the website. Was AFK, did you manage to solve part 1? Yes, I did. It was not pretty. I manually crafted some paths to get it to work. It was really, really grotesque. Really, really grotesque. GG, yo, thank you, appreciate it. This is not going to run in any sort of meaningful time. And I already have some ideas. Because what's going to happen here is these strings are going to get completely unruly. But it worked. It worked. As long as it does the job. Exactly. Exactly. You guys are awesome. Because it worked. And I think I have the logic in my head to make it work, but like to be able to programmatically generate it, but I don't know if I care. These puzzles stretch me to my limit. So here's the thing. We returned this giant string. And I think returning this giant string is not useful. So instead, we need to cache them. I immediately reach for memoization, but I don't think that's ideal. I think there's a better way to do this, where we just think about them as numbers. So right now we have a large giant string, and different substrings of those will have a different count. So this is no different than that linens question. I feel like it's very similar to that, where we kind of just like cache, C-A-C-H-E, cache them out. I feel like we got to do something like that. So let me think about how I would do this, because these strings are going to get absolutely unruly. So now that we're here, let's create a new called cache, and we'll redeclare it for each time we do a new one, so it'll be brand new. When we calculate steps for directional, we should cache it. Is your bot lacking, or did it filter my message? It filtered my message. Did my bot filter your message? Or did YouTube? YouTube is kind of weird about messages sometimes. But did my bot actually filter it? If my bot filtered it, that's overly aggressive. I don't want my bot doing anything. So if my bot filtered it, that's not right. That should not be happening. And I'm not happy about that. Did you get the number for the example solution? No, that's the worst part. They didn't give me a number for the example solution, so I don't actually even know what the new number is supposed to be. So that's super annoying. I'm looking up my bot protection thing now. I don't have my bot set up to do anything. My bot should not be doing anything. You might even have to pay for it to do some moderation. That's what your bot filtered. Oh, interesting. No, okay. Can I ask you, do you know that my bot filtered? Because I have a bot in here. Oh, okay, yeah, because I suspect it's YouTube. YouTube is super duper weird. Like YouTube will just like not show people's comments, which is super dumb. Okay. When we calculate steps, I know what we should do. We should do this. We should keep a frequency count of all the steps that we encounter. And then we should return it in a way that we could read it back in. Oh, this is so gross. Bad cop, if you're here, I'm doing some like illegal things in Bash. I swear these are so gross. I'm like quoting things and then reading them back in. It's so gross. Oh my God. It's just not showing. I posted like 4 times now. What is this? Held a message. Smart detection. Beta. Yeah, it's, you know what? Twitch is auto mod, so it's not my bot. It is not my bot. I'll allow your message to come through. Yeah. Okay. Well, thank you for that. I appreciate it. Yeah, it was, it wasn't, that's so weird. Twitch showed me that it held your message. YouTube did not. That's why YouTube kind of annoys me. So if we do this, calculate steps, numeric, I don't know, what's a good one? Okay, here's how many of each we've encountered. Yeah, that's super weird that you had to go through all those stupid steps like that. That's super annoying. I'm trying to think of a clean way to do this. I literally might just, we're getting gross here. Okay, we're just going to do that. Every time we calculate steps, we're just going to print a new line separated list of steps so we can read them back in to an associative array. And then how do we pass these back in? Anti-spam measure. I think it is. Yeah. YouTube's really finicky though. Like anything that looks like code, it blocks because it thinks it's like a scam or a spam thing or something. And I'm like, dude, I have a programming YouTube. Like my people who comment on my videos are gonna post code. Like, dude, come on, bruh. It's so stupid. And we give it the, yeah, here we go. I have no idea if this is going to work. I'm making up the solution as I go. Perseverance. Yo, NNBB, thank you so much for the $10 super chat. Listen, man, I should give up. I should stop. Oh my god. I'm gonna take a break. I'm gonna take like a 2-minute break. I have a terrible ringing in my ears, dude. It's really bad. I get bad tinnitus. I have it all the time, but it's really, really acting up right now. So I'm gonna go step away for a minute. I'm gonna grab an ibuprofen. I'll be right back. All right, I'm back. That's the ring in my ear right now. It's an A. It's terrible. Super annoying. What am I even doing here? I'm just like making up code, aren't I? Okay. Tickle those ivories, bruh. That's the worst thing I've ever read. Get mods, get him out of the chat. I don't endorse that. Tickle those ivories. Yo, what a comment. I love it. All right, what are we doing? What are we doing? This returns all the steps you need to take separated by new lines for a code you give it. Then I have to give all those back to another call to calculate steps. Okay. So. My ears ring as well. Never thought to identify the frequency. LOL musicians. Hey, I like to. I don't know why. It's just something I do. Yeah, it's been really calm lately. Okay, I'm going to say something really crazy. It's not really crazy. Getting a lot of like health stuff under control, allergies and stuff like that, and focusing on trying to deal with tension headaches, staying hydrated, stuff like that has helped a ton with the ringing in my ear, but it still just comes back. It's really loud in my left ear right now. I don't know why. It still seems to just randomly happen. Yeah, I was going somewhere with that. I forgot. It sucks, but it is what it is. Okay, so we calculated the steps, and then we counted how many we needed to do. So now, in order to pass this into this function, let me try this. No. No. Declare cap A, foo high equals 1, foo by equals 2. What are some ways we can pass this data? There is a way to do this. There's a way to do this with both keys and counts. Okay. Okay. This is how we can pass that data with a K. Yeah, we're going to do some bash voodoo here. I'm just trying to think of the cleanest way to do this. We have all the data we need to step over. I think we just need to step over it. I think we need to do a for key in steps. Do done. Value equals steps at key. Okay. Now we're looping over each one with just a frequency. We can call we can declare dash cap a new steps. Now we can call calculate steps directional with the key, and then new steps at, we have to loop over all the output from this. Oh my god. New steps at line plus equal the value, because that's how many times they would have to show up. Okay. And then to get the length, we need to loop the steps. Get the value and do len plus equal value. I don't know if this is gonna work at all. I'm making up syntax. Well, that didn't work. God. In part 3, there are 77 robots. The direction keypad is rotated 180 for all the odd number robots. Okay. $1 million idea, and I feel like Eric would appreciate it. Going through Advent of Code and adding user added DLC part 3. Adding part 3s. Or even just Eric adding part 3 as a DLC would be unreal. It'd be really funny. Dear God, please no. Oh, it'd be so funny. I might be going crazy right now, but you know, I think it's a good idea. New steps line. Oh, you know what? This might be unset. Well, this isn't right. It would have to be a reverse DLC. Eric pays me to solve them. Listen. Agreed. I've already been brutalized by part 2 so many times. Yeah, but you know, come on. It'd be kind of fun. Oh, man. It's the same thing. It's the same thing, but we have a different way of getting answers, so I don't think this is working. Bar dump steps. Let's just get an idea of what these look like. We don't have var dump. Okay. And then what we'll do is we'll put an exit here. So we'll just only process one. Okay. Funny said. This looks right. This looks like the steps we would have to take. Now, we are leaving out the button press to A. Yeah, I think we need to leave that in there. Maybe try to see if the loop still works with 2 steps. Good idea. That doesn't work. Because when it does 2 steps, for that example, we should be getting something. 68 times 29. And we are getting 29 times 4. But that's okay. We got to figure out what's going on. We're var dumping steps here. Oh, yeah, I know exactly why it's happening. Because we have to copy over the array. We have to copy an associative array in bash. Do you know how to do that? It's really dumb. For key in new steps. Steps equals empty array. We're going to empty out steps. And now we have to loop over the key in new steps and copy them over to steps. There's no good way to copy it is basically my point. You have to just iterate over the keys in the new one and dump them into the one you want. Didn't even know bash had associative arrays. Yeah, welcome to the future. I think 2010 they were added or sometime around them. There we go. 812? Hey, that's better. Okay. This looks a lot better. This is looking a lot better. Let's just make sure we're not off by 1. 68 times 29. That's actually right. That's actually right. That's actually right. We may have been off by 1. I don't know why. I do not understand why. I truly do not understand why. I don't care. 126384. That's the right answer. That's the right answer. If I give it my real input, 197560, that's the real answer. That's the real answer. So, I think we just changed this to 25, right? Do you guys think this is right? I literally, okay, for this solution, I copied the same way that we solved the, oh, what solution was it? The blinking stones. This was the same solution for the blinking stones, was batching up the patterns and how many times we saw the pattern. So a basic memoization kind of style technique. So close. So close. It's okay. It's okay. We tried. We tried. We tried. We'll get there. Funny story, when I first tried AOC and Bash, I didn't know it had associative arrays because I was doing it on a Mac, and I tried to do it with only dumb arrays. Now that is hard. Yeah, I'm doing it on a Mac as well, but I'm using the homebrew version. So I have the newer version of Bash. Otherwise, if you use the built-in one, yeah, you are screwed. It sucks. That didn't work. Now, do we think it could just be a less than equal to 25 thing? It could be an off by 1 issue. One directional that I'm using. Oh, right. 25 are robots. 1 is me. So that would actually explain the off by 1 situation, wouldn't it? That actually would explain that. Yeah. Kind of want to try this. I know they limit how often you can put an answer in. I don't plan on spamming them with answers, but like, maybe. Ah. Your answer is too low. Does anyone remember the first one? Was it too low as well? Too high. Okay, thank you. Wow, so somewhere between those two. Here's what I'm doing. I'm just going to write these down. Let's just open up notes. We at least have a ballpark now. The real brewer part is when they stop giving you higher or lower, so you can't binary search using just form submissions. Yeah, exactly. So according to into string in the Twitch chat, it is 151 whatever, and I'm getting 175. So I am too high with this. This is giving us just ever so slightly too high of an answer. So it's time to look through this logic and figure out what we're doing. First thing we do is we calculate the steps numerically for it. Awesome. It's interesting that it works for the first two iterations, then it breaks on later iterations. That's super interesting. We loop over the steps that we have, we get the value, we loop the data, and we store it. We plus equal by... Let me think about this. Let me think about this. This value... Yeah, no, this is right. This is right. We clear out steps. I mean, let's just do this just to make sure, but I mean, we wouldn't have gotten the right answer without it. And then we just do it again. Oh, hold on. We just did len plus equal value. Is this right? No, the value is just the number. The key is the stringified version of it. The value is how many times you showed up. It should be the length of key. But then how would it have been right? The length of key times the value. How many times it showed up? This isn't right. Yeah, that's way higher. No. Maybe. Yeah, way higher. Okay, that's good. Computer just gave me a warning. Sorry if that was a jump scare. Let's bring this back down to 2. Yeah, see, that's way too high. The length is how many times... Yeah, the length is the string length. I don't understand this. Yeah, so to create the string, you take this and you multiply it by this, and that's how much it shows up in there. There's no way I just got lucky. There might be more patterns here than I'm seeing. That's right. This is right now. And if I give it the real input, it should be 197560. 197560. I need to look at what I was doing before. Something wasn't right. I don't know how I was getting the right answers. So if I do this with the example, I get 175. I don't know if that's right or not. I don't think it is. Let me do it with the real input. PSA, just 3 more followers to the 250 goal. Anyone who's now watching, please click that follow button if you haven't already. Yo, what a message, bro. What a message. You would think it's me. That's right. If you're watching on Twitch and you like what you see and you didn't get upset that I got all frustrated and that doesn't bum you out and you actually kind of enjoy that, hey, go ahead and hit that follow button. Welcome. Welcome to the Twitch chat. If you're watching on YouTube, you've probably been here before, but if you haven't hit that subscribe button, go ahead and hit that subscribe button because I make awesome stuff for this channel and I got a lot of cool stuff coming. So yeah. All right, do it with the real input. What do we get? 2775549. We look in the notes. 2775549. Okay, so we're getting the same thing using a way different algorithm. I don't know how that works. I do not know how that works. I'm gonna be so real with you all. Now we're less than 25. Good. And like this is not, it's the same exact number. I do not understand how that was working. Yeah, we keep track of each pattern we see and how many times it shows up, and to calculate what the length of the string would look like of the final sequences, we just multiply the length of this times how many times it appears. That's how we are doing it. Yeah, so let's change this back to 2. Use example input. 126384. That is correct. 379. Yep. 456. 64. That's right. 179. 68. That's right. 980. 60. That's right. Okay. Use the real input. And we get 197560. That's correct. And then we change this to 25. It's the only difference here. We run it with the real input. It takes a little bit longer to run, but it still runs. And we get this 27755 number. Which is this one, which is too high. Like, I'm going to try and submit it just one more time, just for good measure, but I think it's not right, right? Yeah. This hasn't changed, has it? No, we still got the same stuff. I don't understand how this algorithm just falls apart when it has to do 25 iterations, because it's so simple. It's so, like, stupidly simple. Does bash at any point truncate long strings or numbers beyond any limit? I don't actually know the answer to that question, to be honest. Like, I know it has 64-bit integers, but I actually don't know what would happen then. I think we're well within the range of a 64-bit integer, aren't we? Because those things can be gigantic. Let me just make sure by, like, subtracting 1 from it and it works. Yeah. Yeah, well within 64. Yeah, I would think so, yeah. I don't know what bash does if you, like, make a really, really large number. Like, if I was, like, gonna do, like, a... You might get a number... Oh, no, it just overflows. Or just, yeah, it totally just overflows. Huh. That's fun. I actually didn't know that. Oh, I'm not showing my terminal. That's all I was doing. So, yeah, it totally just overflows. All right, let me reread the problem, make sure I'm not doing something stupid here. One directional keypad that you're using, 25 directional keypads that robots are using, one numeric keypad on a door that a robot is using. Cool. Okay. Yeah, I don't think there's any trickery going on here. The puzzles literally just do this a bunch of times now. I'm making things up now, so we're just trying the you know, classic off by one isms. Yes, that's the low one. Okay. So this is it, but it's just off. It's somehow just off. And I do not know how. The only thing I can think of is if I got some of my pathing wrong. So like, think about it. If I got some of my pathing wrong, but it was never a path that we exercised, which I don't even know how that'd be possible. Yeah. Yeah, left should always be close to the left. Unless they absolutely cannot be. So this one for A1. Yeah, we have to go up and then left, left. For A7, same thing. A4, same thing. A5 and A8. Now we can do left first. Awesome. I'm just making sure that the lefts come first unless they can't. Like 0 to 1, yeah, we can't go left first. 0 to anything on that side, we can't go left first because we'll just go out of bounds. That looks good. Left down, right up, right up, right up. Yep, we have to go that way. Same thing, we have to go that way. Down, down, right, that looks right. Left, down is right. These all look good. Right, right, down, down, down is a little bit weird, but it has to. It has to do it that way. Down comes first. Awesome. Right down. That's right. Left down, down's correct. Correct, 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 correct. Right, right down. That one's correct. Okay. Yeah, those are all right. So man, why are these answers wrong? I cannot figure this one out. And we get the key and we get the value. And we multiply them together and then we add that result to length. So like this key shows up this many times. We multiply this length by that. And that's how many times that would appear in that string. Can you run the example data with 3 iterations for me, please? Sure, why not? Three 10188. That's correct. Huh. Interesting. I'll make it an argument. If we do 2 iterations, we get 2, 4, 2, 5, 6. That's not right. Oh, no. 1, 2, 6, 3, 8, 4. The bottom one. Which is correct. Yeah. 1, 2, 6, 3, 8, 4. Yep. If we run it again with 3, we get whatever I just told you. 310, 188. Yep. If we run it with 4, 757, 754. You know what I can do? I can do this. I'll run them all. Well, that's not right. This is what I have for them. Oh, you said 5 was not correct? Interesting. What kind of bug do I have that manifests that late in the run? This is fun to watch. Four is correct, 5 is high. Interesting. So I am skewing high then. That's super interesting. And then of course, you know, the next ones are going to be just way higher. Interesting that I'm skewing higher here. I wonder what's causing that. I like the way you wrote it. All right. One, 8, 8, 0. Sorry. 1, 8, 8, 1, 0, 9, 0. Thank you for doing that. Wow, I'm just ever so slightly wrong. Interesting. I wonder why. Let me think. I'm surprised I'm high here. I would expect to be low, if anything. Yeah, it's super interesting. Okay. Oh god, it's already. Oof, it's getting late. It's an alarm so I don't sleep in tomorrow. Okay. Let's see. Memory leak. Can you show the piece of code where you copy thing from hash map to another? Yeah, I'll show that. Give me a second. I'm chasing what I think might be something. 1, 2, 6, 3, 8, 4. Where do I copy it? Oh yeah, here. I make new steps. I load into it right here. And then I recreate steps and then copy from new steps into steps. I'm wondering how I just get slightly off. Just blabbering for a second. All right, you do you. My gut is telling me in my steps logic. I don't know. I do not know. Eight of 7 is special. 8 of 4 is special. 8 of 1 is also special. Okay. Those are the special ones. 0 to 7 is special, 0 to 4 is special, yep, 0 to 1 is special. Yeah, all these look right to me. I'm just looking to see we're not leaking any global variables or anything. How do did I get a file named hyphen? Cool. I have so many random slash and exclamation mark files lying around. Yeah, dude. 100% I feel that. I always get like a file like :WQ in my directory. I'm like, oh yeah, that's solid. I'm doing good work here. Dude, I'm lost, man. I feel like this should work. I'm stumped. I don't think this is right. I don't think this is right, and I'm going to throw this out, but like... And now it's too low, which is good. That's what I wanted to have happen. I didn't want it to be right. Wait, am I getting the too high number now again? And now I'm getting the too high number again. What am I changing? Yeah, I cannot figure this out for the life of me. Why does this work? Why is just the length of one? How many times they appear tells you what the next one's going to be. Like, I don't even understand how that logic works. Gotta go. Great job in solving so far. Super impressed. Good luck on the rest. Maybe part 2 tomorrow or next time you stream. Honestly, yeah, I might have to do that because I cannot get this for the life of me. But yo, appreciate it, man. Thank you for stopping by. It's awesome. Problem is now I'm making changes. I don't even know what I'm changing. Like, why is this now off again? Am I leaking variable names or something? It's the only thing I can think of. Calculate steps. Len, code, all steps. Why did I declare something called all steps? Anything majorly different about the real input versus the example? But no, they're like look at this. Like, they're just different numbers. Like, that's literally all that's different. Gotta go as well. It's late for you, Dave. So yeah, maybe indeed take a break today and continue tomorrow. Possibly. I'm locked in right now. So I might go for another like 20, 30 minutes. But yeah, anyone else jump out, dude, I completely understand, man. Go take off, do your thing. I mean, I've been streaming for over 6 hours, so that's wild. I don't know why I do this to myself. Tomorrow I'm looking forward to doing nothing. Well, I have to wake up early. I have people coming over to do some work, and I also have a job. But but I mean, after work I plan on doing nothing. Oh my god, I crack myself up. Yeah, why am I getting that now? Well, I guess the example input is the one that matters. I'll stick around for more 30 minutes. Yeah, you don't have to. If you want to go, feel free to just head out. I won't be upset. I won't be upset. Apparently my answers are just slightly too high. And that's super interesting, isn't it? Why would this output nothing? When would I ever hit this scenario? I coded defensively for a scenario that I'm not sure happens. It's not the worst thing in the world to do that. I just don't know why I did that. Yeah. Should just never hit. Hmm. I mean, this is cool to watch. You can watch it grow. Yeah, this is stumping me. I'm thinking about the logic in my head. It should work. The only thing that could happen is if, like, if I'm encountering paths I haven't walked before, but I don't think I am. Like, the difference between here and here, they're all the same paths. It's just a different number of times they've been walked. Like, these are all the same. Alright, I'm hopeful we're going to figure this out. I would very much like to figure this out before I have to go to sleep. Because I'm invested. I'm absolutely invested. Alright. Loop over all the codes that we read as input. Create a new array. Calculate every step required to create that code on a numeric thing. And then create a frequency count of them. Let's exit here. This is right. In order to create 029A, starting at A and working our way to 0, we'd have to press these, not necessarily in these order, but here's how many times we'd have to press each one of these patterns to do it. And this seems right. Because in order to go from A to 0, we'd have to go left and then hit A once. Cool, we have that here. In order to go from 0 to 9, we'd have to do up, 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 right A, or right, up, up, up A. Up, up, right A. Yeah, that'll get us from 2 to 9. Yep, and then to get from 9 to A, we'd have to go down, down, down A. We have down, down, down A. And then, was that everything? I think that was it, right? A to 0, 0 to 2, 2 to 9, 9 to A. Yeah, that's it. Cool, so that, I mean, that makes sense. That's right, that's what we had to do. We lose the order, but it doesn't matter the order. It just matters how many times we had to do each pattern. Then we loop over those patterns, steps and steps. We loop over those patterns, and we pass just each individual pattern. So we loop over them. We pass each pattern to calculate steps for a directional thing. And then this returns more output, and then we store it in a brand new array. And we plus equal the value. So if we saw that one time, we only calculate it once, and then we just plus equal 3 for that. I mean, this should all work. This logic is solid. We create a new array called steps. We loop over new steps. We store the new steps key into the value. Steps equals key and value, and then we've already done steps. Like, I cannot see what is wrong here. The only thing I can think of is there's like maybe moves at the beginning or end that we need to chop off that we don't care about. I don't even understand. I cannot figure this out. Hey, buddy, how's it going? Ash, I'm barely hanging in here. It's fun. I'm enjoying it. I like this, but... And I needed this. I needed to just sit down and do some coding for fun. I've been missing this. 6.5 hours. Dude, I'm crushing it, man. It's fun. I'm so close to the answer. Like, I know I'm so close. Whatever my mistake is, it's really, really stupid and really, really simple. Like, I just know it. Like, I know it. I know it. It looks pretty. Thank you. I do like the output. I think it's really, really cool. And even though I'm not getting the right answer, I like this because I feel like I know how to do it. So it's a really nice, it's like empowering the feeling. But yeah. There's only a small number of patterns that I ever see. It's actually crazy if you think about it. That was my example. And dude in the Twitch chat said the example should be 154. Mine is 175. Mine is just slightly too high. And I seem to get off kilter around the 5th iteration. I don't know what happens at special at 5, but, you know, hey, it's where we are. Which is so interesting. Like, why would that happen? Why would it just get off step there, like so many iterations in? I don't think it's any weird bashisms. So, like... This is not going to work. I mean, it'll work. It'll just be slower, but I don't think this does anything. I remember reading in your chat, day 18, I think this one was difficult. Yeah, I was warned about this one. I was absolutely warned about this one. Yeah, I get the same answer. So it's not that logic that's making me sad. Can you print out which iteration you first see a particular move? Then if one first appears at the 5th iteration, maybe it's dodgy. Right. But here's the interesting thing. I know what you're saying, but take a look at this. We'll do 6 iterations of the example input, and I'll show just the first one. So you can see here, like, this is how we start. And then as we start getting down to the iterations, no new moves show up. Like, they're all the same moves, just the amount of times we see them is different. So, like, we're not seeing any new moves here. We're only seeing these, 10 moves? Yeah, it's just the amount of times we see those 10 moves is what goes up, which is super interesting. Like, by the second iteration, we've seen every move, it looks like. Or maybe, like, one less than every move. It's just for some reason around the 5th iteration. So here, our count is just wrong. We're off by who knows how much we're off by. But enough to make a significant difference. Yeah, so for Andre in the YouTube chat said for iteration 5, he got 1881, and I'm getting 1893. So I'm like ever so slightly higher. Oh, what is happening here? There we go. It's interesting, I don't see all the patterns show up. Like, it seems like there's a lot more than like 10 different combinations of patterns. But I guess we're not, yeah, we're only doing certain codes. I don't know. It's so weird that I get the right answers. But when I get up to like a very large number of iterations, it just breaks. That's so strange, right? Loop over steps. Again, how many times they appear. Call calculate steps with the key, which is the things we need to do. And then for every one that appears there, we just plus equal it by the value. That makes perfect sense. We don't need to call it a multiple times. Yeah, I mean, this logic is absolutely sound. What if I made simple.text and we want the person to press 0? Just 0. For one iteration. Okay. In order to make a robot press 0, they would have to go to the left and then hit A, and then that's it. They would have to go to left and hit A, and it would just press 0. And then in order for that robot to work, they would have to go down, left, and hit A. Then I have to go right, up, and hit A. Yeah, to just make it go left once and then hit A once. I mean, that makes sense. In order to make that robot do that move, we need a robot that does some of these moves. We don't even know the order that it's going in. Next, we need it to down, left, A. So in order to make it go down ourselves, we'd have to make it go left, down, A. Left, down, A. Yep. Then we'd have to commit that move, so we'd have to go up, right, A. Or right, up, A. Oh no, down, left. Yeah, we'd have to move to the left and hit A once. Then we'd have to hit A again on its own. This sucks. Let me just try something. This shouldn't make a difference. I mean, this does make a difference. It shouldn't. Are we off by 1 now? No, but we just completely broke it. Okay. Should be 126,384. How did that break things? It's all good, NMBB. Take care. Have a good night. I'm gonna hang around for a bit. I really want this, and I feel like my mistake is gonna be so simple. This shouldn't make a difference. That made a difference. All I did was swap a right and an up. Why would that make a difference? That made a difference. I changed one thing. I don't remember which line I changed. I changed like an upright to a right up. That's all I did. That's literally all I changed. And if that fixed it, I actually don't know why. This is a new score. It's giving me a new score. That shouldn't have changed anything. I just had like a hunch. This is a brand new score. This could be it. I don't even know if anyone's still here. If you're here, get ready for a volume warning depending on what happens here. Okay. Okay. Oh man, people are still here. Awesome, awesome. That's not right. It's still not the right answer, but it's different. Like what? Dude. Here's the crazy thing. This is what int2string said would be the correct example. That's the crazy thing. int2string said this was the correct example, meaning what they got for the correct example. That's what I'm getting here. I'm getting this for the example. Yeah, no more too high, too low, which is super weird. Yeah, I don't understand. Apparently I can get 25 iterations of the example input and get the right answer, but I can't do it with the real input. Which is super strange. I'm going to write that down just so I have it. I might even have to, I literally might have to go look at the VOD to see what I changed because I don't even remember. Like I literally changed like a right down to a right up or something. Or an upright to a right up. I don't even know. All right, we're going to change line 20 of this file. 24312. 277. Yeah, that makes a huge difference. So maybe up has to come before right? I don't know why I would prefer that. It wouldn't make a difference to me. In my calculations, up and right should have been the same. Which one did I say came first? I don't even remember. Right? Did I make right come first? Yeah, or up come first? Yeah, we just preferred up for no reason. We'll put the right last. Sure. All I'm doing is putting right after up where I can. With no idea why. I have no idea what that could even change. I'm getting the correct example. That's way higher. Wait, is it 2433 and then 0752? 243. Oh no, it's different. This is just a different number, isn't it? No, it's the same number. Dude, what is happening, man? Yeah, it's not that because that one was too low. And it just said it was wrong. It didn't give me any sort of insight. What if I did 26 iterations? That seems way higher, doesn't it? That is way higher. This is a different number. This is a different but slightly lower number I'm getting. What? It's right. It's right and I don't understand why. It's right and I don't understand why. Here's what I did. I preferred left at the beginning, then down at the beginning, and then I didn't care about right and up, but I just decided to put all the ups first, or the rights first, and it was backwards, and I decided just to do prefer left first, then down, then up, then right. I understand left first. I understand down next, but I don't understand up and right mattering. The reason I say that, I mean, thank you everyone, GG, like we got it. The reason I say that is because if we're at the A, getting to this spot down here, the left, it takes 1, 2, 3 spots to get there. So this has a weight of 3. To get to the down position, we have to go 1, 2, or 1, 2. This has a weight of 2. So prefer this one, fall back on this one. These two are equal weight. Why is this one preferred over this one? Why is it preferable to go here? I don't know why. I'm happy I got the solution. I'm very happy I got the solution. I nailed it. I got it. I locked in. 7 hours later, I got it. I don't understand why. I'm not thrilled that I don't understand why. I'll probably do some reading on tonight. Now that I have the answer, I'm happy. Dark space, if you're watching the VOD later, apparently it does matter that up comes before right, or we just got really lucky because it was working with my example on iteration 25, but it was failing on the real example for iteration 25. I'm not confident in this implementation, but we got it. We got there. This was my longest stream ever. Thank you everyone for tuning in. I think I'm going to call it a night here because I am just drained. I am absolutely drained after that. But we nailed it and we only have 4 more puzzles left. So I'm going to call it here. Thank you everyone for tuning in. Much love, much appreciated. You guys are awesome. I truly don't understand how this worked. Like, I have a really good idea of how I got it to work, but like, there are some parts I'm missing on this. So I'll have to go back and re-understand it. Oh man. Yeah, thank you for hanging out live, dude. It's awesome. Ash says, let's do day 22. Why not? Absolutely not. That will be for a different day, sometime in the future. Impressive. Thanks for letting us see you in frustrated mode. We've all been there. Hey, yeah, I'm glad you guys enjoyed it. I got a little heated. I had to step away for a bit and then come back with renewed energy. But it worked. We're good. It's awesome. We got the solution. Somehow magically with the code I wrote, I was able to get the right number. I can't even believe it. I hope the rest of the days are not like this. I hope they're a little bit more fun and more rewarding. Yeah. That's all I got. Thank you everyone for tuning in. I'm going to call it here. I'm absolutely wiped. But yeah, so thank you everyone. I'll see you guys later. Take care everyone. See ya.